Sleep Matters.
Level 1. Atom. An atom is not just a tiny particle. It is the basic building block of everything around you. Your body, the air you breathe, the screen you are looking at, all are made of atoms. But an atom is not just a solid piece of matter. It is a tiny world of energy. At the center of an atom is a dense core called the nucleus, which contains protons and neutrons. Protons are positively charged, while neutrons have no charge. Around this nucleus, electrons spin in a cloud, carrying a negative charge. But here is the mystery: most of an atom is empty space. Even in solid objects, the atoms are mostly empty, with tiny particles moving at incredible speeds. Atoms are not all the same. Each type of atom is called an element. Hydrogen is the simplest atom, with 1 proton and 1 electron. Gold is an atom too, with 79 protons, giving it its golden shine. Atoms bond to form molecules. 2 hydrogen atoms join with 1 oxygen atom to create water. Carbon atoms connect in different ways to form graphite or diamonds. Atoms are not just small, they are the silent architects of the universe. Level 2. Molecule. A molecule is not just a tiny piece of matter. It is a connection, a bond between atoms. Atoms are the basic building blocks of everything, but they rarely exist alone. They are too reactive, too eager to connect. When 2 or more atoms bond together, they form a molecule. Water is a simple molecule, just 2 hydrogen atoms bonded with 1 oxygen atom. This small molecule is what makes oceans, clouds, and even your blood. But molecules are not all the same. Carbon dioxide is another molecule, made of 1 carbon atom and 2 oxygen atoms. It is the gas you breathe out, but too much of it in the air can warm the planet. Molecules can be simple, like oxygen, just 2 oxygen atoms bonded together. Or they can be complex, like proteins in your body, which are made of thousands of atoms arranged in perfect order. The food you eat is made of molecules, breaking down in your body to give you energy. The air you breathe is full of molecules, a mixture of oxygen, nitrogen, and other gases. Molecules are not just small. They are the invisible architects of reality, deciding everything from the taste of your food to the breath in your lungs. Level 3. Element. An element is the simplest form of matter. It is a pure substance that cannot be broken down into anything simpler. Everything you see, touch, or breathe is made of elements. There are 118 known elements, each with a unique identity. Hydrogen is the simplest, just 1 proton and 1 electron. It is the fuel of stars and the most abundant element in the universe. Helium is another, a gas that makes balloons float, but also powers the sun's energy. Gold is an element too, a metal that has inspired wealth and beauty for thousands of years. But elements are not just metals. Oxygen is an element, an invisible gas that keeps you alive. Carbon is another, the foundation of all life, able to exist as graphite or as a diamond. Imagine this. You are holding a silver coin. You heat it, melt it, turn it into a ring. It has changed shape, but it is still silver. That is the secret of an element. It can change form, but never become something else. Every object around you is made of elements or combinations of them. They are the silent creators of everything you know. Level 4. Compound. A compound is not just a mix. It is a transformation. It is when 2 or more elements bond chemically to become something completely new. Water is a compound, but it is not just hydrogen, a flammable gas, and oxygen, which fuels fire. Together, they become a liquid that puts out flames. Salt is another compound. Sodium, a metal that can burn in water, and chlorine, a toxic gas, bond to create table salt, something you eat every day. Compounds are everywhere, from the sugar in your coffee to the carbon dioxide you breathe out. They are the hidden creators of reality. Level 5. Mixture. What happens when you take salt and mix it with water? Do they become something new? Number. They become a mixture. A mixture is not a chemical change, it is a physical blend. The substances in a mixture retain their identities. Salt remains salt. Water remains water. But they come together. Mixtures can be solid, liquid, or gas. Air is a mixture, a blend of oxygen, nitrogen, carbon dioxide, and other gases. Your favorite salad is a mixture of vegetables. Even the soil under your feet is a mixture of sand, clay, and organic matter. But here is the secret. Mixtures can be separated. You can evaporate water to get salt back. You can use a magnet to separate iron from sand. Mixtures are everywhere, but they do not change the substances that make them. They are combinations, not creations. A mixture is not a transformation. It is a temporary gathering, a dance of particles that can always be separated. Level 6. States of matter. Have you ever wondered how a solid mountain can melt into a flowing river, or how a cold mist can transform into a sharp crystal of ice? These are not just random changes. They are the magic of matter changing its state, and this magic is all around you. The states of matter are the fundamental forms that everything you touch, see, and even breathe can exist in. Solids are the most familiar. They have a fixed shape and volume. Think of a rock, a chair, or even the screen you are watching. Their particles are tightly packed, barely moving, locked in place. But add energy, like heat, and something magical happens. The solid can melt, turning into a liquid. Now, particles move freely but are still close. Water flows. It takes the shape of its container, but it does not escape. But there is another level. Heat it more, and that liquid becomes a gas. Its particles spread out, free and wild. This is steam rising from boiling water or the air you breathe. But this is not the end. There are even more exotic states like plasma, a supercharged gas found in lightning or the sun. Matter can even become a Bose-Einstein condensate, a strange state where atoms lose their individuality and merge. States of matter are not just science, they are the hidden dance of existence, changing shape, form, and energy, creating everything you know. Level 7. Atomic structure. Imagine this. You are holding a solid metal ring. It feels strong, unbreakable. But what if I told you that this solid ring is mostly empty space? That it is made of countless tiny particles called atoms? But these atoms are not solid either. They are tiny worlds of energy. At the heart of each atom is a dense center called the nucleus. This nucleus is made of protons and neutrons, tightly packed together. Protons are positively charged, while neutrons have no charge at all. But the story does not end here. Surrounding this nucleus is a cloud of electrons, tiny particles with a negative charge. They move so fast that they create a blur of energy around the nucleus. But here is the secret. These electrons are not just moving in circles. They exist in regions called orbitals, where they appear and disappear like whispers. Most of an atom is empty space. Even in the strongest steel, the atoms are mostly nothing, just tiny particles surrounded by emptiness. And yet these empty atoms come together to create solid objects. Your own body is made of atoms, mostly empty space. But you feel solid, real, because these tiny particles hold together. This is the mystery of atomic structure. A solid world built from emptiness. Level 8. Proton. What decides who you are? Is it your name, your choices, or something even smaller? In the world of atoms, identity comes from protons. A proton is a tiny particle with a positive charge, hidden in the center of an atom's nucleus. The number of protons in an atom is what makes it unique. One proton means hydrogen, the fuel of stars. 2 protons mean helium, a gas that lights up the universe. 8 protons mean oxygen, the breath of life. But protons are not just numbers, they are forces of attraction. Their positive charge pulls negatively charged electrons close, creating the structure of an atom. Without protons, there would be no atoms, no elements, no universe. They are held together in the nucleus by an invisible force called the strong nuclear force, one of the most powerful forces in nature. It is so strong that when broken, it can release enormous energy. Protons are not just particles. They are the keepers of identity in the atomic world. They decide the nature of everything, from the air you breathe to the stars you see. They are the silent creators of matter. Level 9. Neutron. What keeps everything from falling apart? What holds the very center of matter together without anyone seeing it? That secret is the neutron. In the heart of every atom, in the nucleus, there are 2 main particles, protons, which are positively charged, and neutrons, which have no charge at all. But do not let that silence fool you. Neutrons are the quiet force that holds everything together. Protons, with their positive charges, should repel each other, pushing away like 2 magnets with the same pole. But they do not. They stay together because of the strong nuclear force, and neutrons are the key. Neutrons act as a buffer, a silent protector that keeps protons from flying apart. But neutrons are not just a part of the atom. They are also the source of nuclear power. When a neutron is released from an atom, it can collide with another atom, causing it to split. This is nuclear fission, the force behind atomic energy and nuclear explosions. Neutrons are quiet, but they are powerful. In the world of atoms, they are the silent guardians. Without them, there would be no stable atoms, no elements, no matter, and no universe. Level 10. Electron. Imagine being in a crowded room and yet never finding a place to stay, constantly moving, always spinning around but never being the center. That is the life of an electron. It is the restless child of the atom. It moves at almost the speed of light, racing around the nucleus, but it never truly settles. It is negative, always searching for something positive. It is the spark that creates electricity, the force that powers your world, but it is also the cause of chaos. Electrons decide how atoms connect. They decide which atoms become friends and which become enemies. They are the ones who make chemical reactions happen, but they are also the ones who cause explosions. It is the electrons that make your phone work. It is electrons that make you see light. It is electrons that make your heart beat. But they are never still. They are never stable. They are the energy of life, but they are also the root of restlessness. But what is an electron really? It is a particle, but it is also a wave. It is here, but it is also everywhere. It is certainty, but it is also a question. That is the secret of the electron. It is a paradox, a thing that exists, but also a thing that cannot be pinned down. Just like thoughts that keep racing in your mind, just like emotions that never seem to settle, just like the feeling that you should be somewhere else, doing something else, being someone else. The electron is the symbol of restlessness, of never being enough, of never being still. But here is the hidden truth. The electron is also connection. It is what allows atoms to share. It is what creates bonds. It is what makes a molecule. Without electrons, atoms would be alone. Silent, lifeless, just like people who are isolated without their friends, just like lovers who are close but never truly connect. The electron is energy, but it is also loneliness. It is movement, but it is also escape. It is the thing that never stops, but also the thing that creates everything. It is not just science. It is the human condition, spinning endlessly, searching for something it can never fully touch. Level 11. Atomic number. Every person you have ever met is defined by something you cannot see. It is not their smile, their voice, or the way they walk. It is something much smaller, something deep inside. For atoms, this hidden identity is called the atomic number. It is the most important number in an atom's existence. The atomic number is not just a label, it is a promise. It tells you how many protons are in the nucleus of an atom. That number decides everything. If an atom has 1 proton, it is hydrogen. 2 protons, and it becomes helium. 8 protons, and it is oxygen. Change that number, and the atom stops being what it was. A single proton can turn a gentle gas into a burning flame. It can transform something that gives life into something that takes it away. This is not just chemistry. It is a story about identity. Just like people are defined by their deepest beliefs, atoms are defined by their atomic number. But this goes deeper. In life, you can wear different clothes, change your style, speak with different words, but your true self is decided by something deeper. Your core values, your principles. Your sense of right and wrong, that is your atomic number. You can add things to your life, money, friends, skills. You can lose things. But as long as your core remains the same, you are still you. But if that core changes, you become someone else. And this is not just a theory, it is reality. Think about someone you used to trust. They were always kind, always honest. But one day, they betrayed you. Not just a mistake, but a choice. A lie so deep that it changed how you saw them. It was not just an action. It was a shift in their atomic number. Their core changed. And once that happens, nothing feels the same. Atoms are defined by their protons. That number never changes, but in people, the core can be shaken. A kind person can become cruel. A loyal friend can become selfish. The number of protons in an atom is a rule that cannot be broken. But for humans, identity is a choice, and that choice can be lost, or stolen, or simply forgotten. That is the danger of not knowing your own atomic number. You become whatever the world wants you to be. But atoms are not so weak. They know what they are, and they do not change for anything. Level 12. Mass number. If the atomic number is an atom's identity, then the mass number is its weight. But this weight is not like the weight of your body. It is not something you see on a scale. It is the weight of the nucleus. The weight of the core. The mass number is the total of protons and neutrons inside the nucleus. Protons give an atom its identity, but neutrons give it balance. Too many protons without enough neutrons, and the atom becomes unstable. It begins to break down. It releases energy. It becomes radioactive. That is the silent truth of balance. Even in the smallest parts of the universe, balance is life. Imbalance is decay. In life, this is true as well. You have your identity, your core values, your beliefs, but you also have your experiences, your memories, your regrets. These are your neutrons. They do not change who you are, but they change how you feel, how stable you are. A person who is honest but has suffered betrayal may become cautious. Someone who is loving but has been hurt may become guarded. That is how the mass number works. It is the weight of everything you have been through. And just like an atom, too much weight can make you unstable. But here is the danger. People often confuse their mass number with their identity. They believe that their pain defines them, that their failures are who they are. But that is not true. Your atomic number is your true self. Your mass number is just the weight you carry. And weight can change. You can let go. You can heal. But you cannot change who you truly are without changing your core. Atoms with the same atomic number but different mass numbers are called isotopes. These are versions of the same atom with different weights. Some are stable, others are radioactive. This is true for people too. Some carry their memories lightly. Others are crushed by them. Some live with joy despite their struggles. Others are poisoned by their past. That is why knowing the difference between identity and weight is so important. Because your experiences do not define you, your choices do. Level 13, Isotopes. An isotope is not a different element. It is a different version of the same element. Every atom of an element has the same number of protons in its nucleus. That is what makes it that element. Hydrogen always has 1 proton. Carbon always has 6. But atoms can have different numbers of neutrons. These variations are called isotopes. Think of them like brothers. They share the same family name, but they are not exactly the same. Carbon-12 is the most common form of carbon. It has 6 protons and 6 neutrons. But there is also carbon-14, an isotope of carbon, which has 6 protons but 8 neutrons. This small difference makes carbon-14 radioactive, which means it can decay over time. This is why carbon-14 is used in radiocarbon dating, a method used to determine the age of ancient objects. Not all isotopes are radioactive. Oxygen has 3 common isotopes, but none of them are dangerous. Hydrogen has 3 isotopes: protium, deuterium, and tritium. Tritium is radioactive and used in nuclear reactors. Isotopes are not just science, they are history. They are the clocks of the universe, silently measuring time. They are the quiet variations that make the world more complex. Level 14. Ions. An ion is an atom that is not balanced. It is an atom that has either gained or lost electrons, giving it an electric charge. Normally, atoms are neutral. They have an equal number of protons, which are positively charged, and electrons, which are negatively charged. But when an atom loses an electron, it becomes positively charged, and when it gains an electron, it becomes negatively charged. This charged atom is called an ion. Think of an ion like a person who has borrowed or lost something valuable. A sodium atom normally has 11 electrons, but if it loses one, it becomes a positively charged sodium ion. It is now incomplete, eager to bond with something else. Chlorine is the opposite. It has 7 electrons in its outer shell, but wants 8. When it gains an extra electron, it becomes a negatively charged ion. This is why table salt is so stable. Sodium loses 1 electron and becomes positive. Chlorine gains 1 and becomes negative. Their opposite charges attract, creating a strong bond. Ions are not just in salt. They are in your body, controlling nerve signals and muscle contractions. They are in the air, in batteries, even in the water you drink. They are the invisible force that creates bonds and balances in nature. Level 15, Periodic Table. How do you organize a universe made of invisible pieces? How do you understand people when everyone is made of different traits, different needs, different kinds of chaos? That is what the periodic table tries to do. It is not just a chart, it is a map of the invisible world. Every square on it represents an element, something pure, something that cannot be broken down further. Each has a number, a weight, a name, a personality, but together they create the language of the universe. Imagine a giant school with 118 students. Each one has their own way of reacting. Some make friends quickly. Others explode if you get too close. Some avoid everyone. Others are always giving and giving until they disappear. That is the periodic table, a quiet, perfect arrangement of all the elements we know, and behind it, a truth about how we try to sort people. Understand behavior, predict reactions. At the start, no one knew how to arrange them. Elements were being discovered randomly: gold, silver, oxygen, but no one could see the pattern. Until one scientist, Mendeleev, decided to trust something strange. he left gaps, empty spaces for elements that had not yet been discovered. People thought he was guessing, but he was not. He was seeing the invisible logic, and he was right. The missing elements were found later, exactly where he said they would be. This is the power of seeing patterns in chaos. This is the power of trust in what you cannot yet prove. Like when you feel someone is not okay, even if they say they are fine. Like when you leave space for someone who is not ready yet, but you know they will come. Like when you trust the parts of yourself that have not arrived yet. The periodic table is not just about elements. It is about belief that everything has a place, even what you cannot see. Each group in the table behaves differently. The far left side is reactive, elements that burn, that bond fast, that do not last long alone, like people who need attention, who panic when they are alone, who always jump into something before thinking. Then there are the noble gases on the far right, calm, unreactive, happy on their own. They do not bond with anyone, not because they are cold, but because they are already full, already complete, like the friend who is quiet but never lonely, the one who does not need fixing, just space. In the middle are the transition metals, strong, useful, flexible, but hard to predict. They can form many kinds of bonds. They can change forms, but they also wear out, just like the people who do everything, the ones who hold families together, the ones who take on too much and forget their own needs. Each element has a story. Carbon can become coal or diamond. It depends on the pressure, just like people. Hydrogen is the simplest and most common, but it fuels stars. It burns with energy when given the chance, like someone overlooked, underestimated, but powerful when ignited. Fluorine is dangerous. It reacts with almost anything, like someone who is always on edge, always ready to fight, always afraid of being left alone. And helium? It floats. It is light. It does not react, but it also escapes. It leaves without warning. You cannot keep it. It disappears before you realize it is gone. The table looks clean, but it holds every kind of behavior, from the gentle to the violent, from the stable to the unstable. It teaches that order does not mean safety, that even the most perfect chart holds danger, and it reminds you that everything is connected by how it reacts, that your reaction is your truth, not your name, not your shape, not your weight, but how you change when something touches you. So the next time you see a periodic table, remember this. You are not just looking at science. You are looking at a silent record of every kind of identity, every type of emotion, every kind of response. The table may look still, but every square is a different kind of storm, waiting, watching, reacting, just like us. Level 16. Periods and Groups. Periods and groups are the hidden code of the periodic table. A period is a row, and a group is a column. But they are not just rows and columns. They are a map that shows how elements are connected. Each period represents how many energy levels, or shells, an atom has. The first period has only 2 elements, hydrogen and helium, because they have just one shell. The second period has elements like lithium and neon, with 2 shells. As you move across a period, elements change from metals to nonmetals. Groups, on the other hand, are vertical columns. Elements in the same group have the same number of electrons in their outer shell. Group 1 elements like lithium, sodium, and potassium have 1 electron in their outer shell. This makes them highly reactive. Group 17, the halogens, have 7 electrons, making them desperate to gain 1 more. Group 18 is the noble gases. They have full outer shells, making them stable and unreactive. Imagine this. You are walking down a hallway lined with doors. Each row is a floor, each column a corridor. The elements in the same hallway behave alike, like a family sharing the same habits. This is the secret of periods and groups. Level 17. Alkali Metals. What if something could be so powerful that it reacts violently the moment it touches water? What if something so soft and shiny could turn into an explosion in seconds? These are alkali metals, the most reactive elements in the periodic table. They look harmless, silver, and soft, like a piece of jewelry, but the moment they touch water, they come alive. Sodium, a metal you can cut with a knife, bursts into flames in water. Potassium, even more reactive, explodes with violet light. These metals are not just dangerous, they are desperate. They have only one electron in their outer shell, and they will do anything to give it away. They do not bond gently, they attack, they burn, they explode. But in that chaos, they create. Sodium is part of salt, the most essential seasoning in your life. Potassium is in your body, controlling your heartbeats. These are the metals that give life, even when they are deadly. They are a paradox, a silent threat that is also a silent gift. But why are they so reactive? It is because they are incomplete, always trying to become stable, always seeking something to take away their loneliness. Level 18. Noble gases. Noble gases are the ones that stand alone. In a world where everything tries to connect, tries to bond, tries to belong, noble gases do not. Helium, neon, argon, krypton, xenon, and radon are the elements that refuse to change for anyone. They are called noble, not because they are special, but because they are complete. Their outer shells are full. They do not need anyone else to be whole, and that makes them different. It makes them powerful, but it also makes them isolated. Because they do not bond easily, they exist as single atoms, floating through the world untouched, unaffected. But that also means they are safe. They do not react. They do not explode. They do not burn, just like some people. The ones who stand alone, who do not open up easily, who keep their thoughts hidden and their hearts guarded. They are strong because they do not let others change them. But they are also alone because they never truly connect. Noble gases light up signs with their glow, but they do not let anyone touch them. They are the walls you cannot break through. The people who stay silent, even when the world is loud. They are not dangerous. They are not hurtful. They are simply self-contained. But even they have their limits. Xenon can be forced to react under extreme pressure. Even the strongest can be changed when the pressure is too much. But the moment the pressure is gone, they return to their silent, untouchable state. Noble gases are a reminder that independence is a strength, but it can also be a prison. That being untouchable can keep you safe, but it can also keep you alone. Level 19. Halogens. Halogens are the exact opposite. They are desperate. They are always searching for something. Fluorine, chlorine, bromine, iodine, and astatine. These are the elements that cannot stand alone. They need to bond. They are incomplete on their own. Their outer shells are one electron short of being full, and that emptiness drives them to react with almost anything. Fluorine is the most aggressive. It is so reactive that it can burn steel. Chlorine is a poisonous gas, but turns into something essential when it bonds with sodium to form salt. Halogens are powerful because they are hungry. They are not complete, and they will do anything to change that. In life, halogens are like people who are always looking for something to make them feel whole. The ones who jump from relationship to relationship. The ones who try to find their worth in other people's approval. The ones who become possessive because they fear losing what they need. But not every bond is good. Fluorine's strength can destroy. Chlorine's poison can kill. This is the truth of halogens. They are a force, but they are also a danger. They show that need can be a weapon. that desperation can turn toxic. But they also show that even the most incomplete can find purpose. When chlorine bonds with sodium, it becomes salt, something essential for life. Even the most dangerous can become useful when they find the right connection. Halogens are not just reactive. They are a lesson that hunger can drive you, but it can also destroy you. It is not wrong to need, but it is dangerous to be controlled by that need. Level 20. Transition metals. Transition metals are the elements that can be many things at once. Iron, copper, gold, silver, titanium. They can change their appearance. They can form different colors. They can bend without breaking. They can be strong or soft. They can be shiny or dull. These are the metals that do not fit neatly into any category. They are versatile, adaptable. But they are also unpredictable. Iron can rust and become weak. Copper can turn green. Silver can tarnish. Even gold, which does not rust, can lose its shine. Transition metals are like people who are always changing, always trying to be something different. They are the ones who can blend into any group, who can be serious one moment and playful the next. They are strong, but not unbreakable. They are beautiful, but not perfect. They can be heroes or villains, depending on the situation. This is their strength. They are not trapped by a single identity. But it is also their curse. Because in trying to be everything, they can lose who they really are. They can become surface without depth, appearance without truth. Transition metals can conduct electricity. They can shine. They can be used to build empires or to make jewelry. But they are never just one thing. That is their secret. They are flexible, they are powerful, but they are also temporary. Even the strongest can corrode. Even the brightest can lose their light. And that is the truth of transition metals. They are a reminder that change is power, but it is also risk. That being adaptable can make you survive, but it can also make you forget who you are. Level 21. Chemical bonds. What makes two people stay together when everything is falling apart? What keeps them holding hands when the world around them is nothing but chaos? That is the mystery of chemical bonds. It is the force that decides what stays together and what breaks apart. It is the silent promise between two atoms that they will not leave each other. But here is where it gets strange. Not all bonds are built from love. Some are born from need, some from fear, some from the simple fact that being alone is more dangerous. Chemical bonds are the connections that hold atoms together to form molecules. They are the invisible hands that keep everything from collapsing into chaos. But there is a truth to them that no one tells you. Not all bonds are the same. Some are strong, some are weak, some are easily broken, some never truly connect, and just like in life, the bond you form decides everything about you. Imagine two people who cannot live without each other. They complete each other. They fit perfectly. That is a chemical bond. But now imagine another pair. One is always giving. The other is always taking. They are connected, but it is not an equal connection. One is stronger, one is weaker, but they stay together because they have to. That is also a chemical bond. In the world of chemistry, there are three main types of bonds: ionic, covalent, and metallic. Each is a different kind of connection. Each tells a different story. But before we get into that, you need to understand something deeper. A chemical bond is not just a connection. It is an exchange. It is a choice. Sometimes it is a sacrifice. An atom can be alone, but it is not complete. It has something it wants to give away or something it needs to take. That is how bonds are born, not from perfection, but from imbalance. From a need to be whole. But here is the darkest truth. Not all bonds are good. Some are toxic. Some are destructive. Some are a trap, just like people who stay in relationships that hurt them. They stay because they are afraid to be alone. They stay because they are addicted to the chaos. They stay because breaking the bond would mean facing the emptiness. That is the danger of bonds. They are strong, but they are also a prison. And sometimes the strongest bond is the one you cannot escape. Chemical bonds are the quiet rules that hold the universe together. They decide what can exist and what cannot. They decide who can stay and who must be broken apart. But now let's look at them one by one. Let's begin with the most intense one. Level 22, Ionic Bonding. Imagine two people standing on opposite sides of a burning bridge. One is strong, confident, and full of energy. The other is quiet, fragile, always feeling incomplete. The first person has too much, the second has too little, but the fire is closing in. They need each other, they reach out, one gives, the other takes, they hold on. And suddenly, they are safe, but only because they are together. This is an ionic bond. It is a bond born from imbalance. It is when one atom has too many electrons, and another has too few. The one with too many gives them away. The one with too few takes them, and they both become charged. One becomes positive, the other becomes negative, and that opposite charge is what keeps them together. Just like two people who only stay together because they are afraid of falling apart. This is what happens when sodium and chlorine meet. Sodium is a metal. It is desperate to get rid of one electron. It feels incomplete. It feels unstable. Chlorine is a gas. It is hungry for one more electron. It is missing something. When they meet, sodium gives away its electron. It becomes positive. Chlorine takes it and becomes negative. And in that moment, they are locked together, not because they love each other, but because their opposite charges pull them together. They become salt, simple, stable. But built from a desperate exchange. This is the story of many relationships. One person gives, the other takes. One sacrifices, the other benefits. But they stay together because the balance of power keeps them trapped. But there is a warning here. Not all ionic bonds are stable. Some are easily broken. Add water and salt dissolves, the bond is destroyed. Just like when someone new comes into your life and makes you question the connection you thought was unbreakable. Just like when distance or doubt slowly eats away at something you thought would last forever. Ionic bonds are strong, but they are also fragile. They are built from a need to be complete. But they can be broken with the right push. They are the bonds of desperation, the bonds of imbalance. The bonds that are more about what you lack than what you love. But there is another kind of bond, one that is quieter, more equal, but also more dangerous in its own way. Level 23, Covalent Bonding. Picture two people standing in the rain, both shivering, both lost. But instead of walking away, they pull closer. They share an umbrella, they share their warmth. They are not trying to escape each other. They are trying to survive together. This is a covalent bond. It is when two atoms share their electrons, not because one has too much and the other has too little, but because they both need something. They become partners, not givers and takers, but sharers. This is the bond between hydrogen and oxygen that creates water. Two hydrogen atoms share their electrons with one oxygen atom. They hold on. They become one. And that bond is not just strong, it is a promise. It is a partnership. But here is where it gets complicated. Not all sharing is equal. Some covalent bonds are polar. That means one side has a stronger pull. One side takes more than it gives. Just like a friendship, where one person is always the listener and the other is always the talker. Just like a team where one person does all the work and the other takes the credit. The bond still exists, but it is not fair. This is the story of water itself. Oxygen is stronger. It pulls the electrons closer. Hydrogen is left feeling a little empty. But they stay together because even an unfair bond is better than being alone. This is the quiet trap of covalent bonding. It feels equal, but it is not. It feels balanced, but there is always someone who holds the power. But then there are nonpolar covalent bonds, true partnerships, where both sides share equally, like two friends who support each other without keeping score, like two lovers who protect each other without fear. This is the rarest kind of bond, because true equality is hard to find, even in atoms, but it does exist. Carbon and hydrogen form this kind of bond. They share perfectly. They create the foundation of life. Everything you eat, breathe, touch it, is made of carbon and hydrogen sharing perfectly. This is the bond you dream of but rarely see. And here is the secret. The strongest bonds are the ones where both sides give. But even they can be broken. Even they can change. A covalent bond can be split with enough energy. Just like two people who were once perfect for each other can drift apart. Just like a friendship can fade. A promise can be forgotten. That is the truth of bonding. Whether it is ionic or covalent, whether it is born from need or sharing, all bonds can be broken. But what matters is not the bond itself. What matters is how it made you feel when it held. What it taught you, what it left behind. Level 24. Metallic Bonding. Metallic bonding is the secret to why metals are strong, shiny, and flexible. It is a type of chemical bonding that is completely different from other bonds. In most substances, atoms stick together by sharing or exchanging electrons, like two people shaking hands. But in metals, it is different. Metal atoms do not hold on to their electrons tightly. They let them go. These electrons become a sea of free-moving particles that flow around the atoms. This is called the electron sea model. It means that all the metal atoms share their outer electrons. They are not attached to any one atom. They float freely, moving between the atoms, creating a network of shared energy. This is what makes metals so unique. Because of this sea of electrons, metals can conduct electricity. The free electrons can move easily from one place to another, carrying an electric current. They can also conduct heat because the energy is quickly passed from one electron to the next. Metals are also strong but flexible. If you hit a metal, the atoms can slide past each other without breaking because the electrons just move with them. It is like a dance, a silent, constant movement that keeps everything together. Visualize this. You are watching a group of children playing a game. They are standing in a circle, passing a ball to each other. But there is a twist. No one keeps the ball for more than a second. It keeps moving, never stopping. This is how the electrons in metallic bonding work. They are always being shared, always moving. This is why metals are so strong but not brittle. Because the bonds can move without breaking. But there is another truth here. Even though the electrons are free, they do not leave the metal. They are still held by an invisible force. The positive metal atoms are like a net, holding the electrons close. They create a balance, a quiet agreement, a community of atoms and electrons that rely on each other. That is what makes metals so different. They are not just strong, they are united. They are a team. In life, this is like a family where everyone shares. No one is left alone. If someone is weak, others support them. If someone is too full, they share their strength. It is not about one person being the leader. It is about everyone being connected. And that is why metals can be cut, bent, or melted, but they never truly fall apart. They are always together. And this lesson matters, because in a world where everyone tries to hold on to what they have, metallic bonding is a reminder that sometimes the greatest strength comes from sharing. Level 25. Chemical Formula. A chemical formula is a simple way of telling you what something is made of. It is like a secret code, but once you understand it, you can see the truth of any substance. Water is H2O. This means it has 2 hydrogen atoms and 1 oxygen atom. Salt is NaCl, 1 sodium and 1 chlorine. These tiny symbols and numbers tell you the exact recipe for a substance, but they are not just letters. They are the truth. They tell you exactly what you are looking at, even if you cannot see the atoms. A chemical formula is a promise. It is a way of saying, this is what I am. I cannot be anything else. But chemical formulas also teach a deeper lesson. They show you that small changes can have huge effects. CO is carbon monoxide, poisonous, deadly. But CO2 is carbon dioxide, a gas you breathe out. One small change in the formula, and the meaning changes completely. It is like a relationship where one word can change everything. One promise kept or broken can change how 2 people feel about each other. One tiny decision can change the entire future. That is what a chemical formula teaches, that even the smallest difference can create a completely new reality. Visualize this. You are baking a cake. You add sugar, flour, eggs, and milk. You mix them together and the batter is smooth, but then you add salt instead of sugar. Just a small change. But when the cake is baked, it is ruined. The taste is gone. That is what happens with chemical formulas. Change one atom, and the entire substance can become something else, something better, something worse, but always something different. This is why chemists study formulas so carefully, because they know that the secret of everything is in these tiny combinations. And in life, this is true too. It is not just about what you are made of, but about how you are put together. It is about the way things combine. Level 26. Molecular Structure. Molecular structure is the shape of a molecule. It is the way the atoms are arranged, the angles between them, the way they connect. And this shape decides everything. 2 molecules can have the same atoms, the same formula. But if their structures are different, they will behave differently. Think of it like 2 people with the same words, but one speaks calmly and the other shouts. The message changes completely. That is what molecular structure is, the silent design that decides everything. One famous example is water. Water is H2O, but the way those atoms are arranged creates a bent structure. This bent shape gives water its unique properties. It makes it a liquid at room temperature. It gives it surface tension, so insects can walk on it. It makes ice float. If water had a different structure, it would not be the same. It would not be life-giving. It might even be poisonous. This is the power of structure. It is not just what you have, but how it is arranged. Visualize this. You have 2 identical keys. They look the same. They weigh the same. But one of them is slightly bent. You try it in the lock, but it does not work. The other key turns perfectly. This is molecular structure. The shape matters more than anything, and this lesson is true in life too. It is not just about having love, trust, or knowledge. It is about how you arrange them. A person who loves too quickly can become desperate. A person who is too honest can become hurtful. It is not just what you are, but how you are shaped that decides everything. Molecular structure is why some substances are solid, some are liquid, some are gas. It is why diamonds are hard and graphite is soft, even though both are made of carbon. It is a reminder that the same ingredients can create completely different results depending on how they are arranged. It is not just about the pieces, it is about the design. Level 27. Valence Electrons. Valence electrons are the outermost electrons of an atom. They are the ones that decide everything. They are the ones that make bonds, that create reactions, that build the world around you. If an atom is like a person, the valence electrons are its personality. They are the parts that reach out, that connect, that change. Most atoms want to have a full set of valence electrons. For most, this means having 8. This is called the octet rule. Atoms will give away, take, or share electrons just to achieve this balance. It is like a person looking for a complete set of friends, a complete set of feelings. Some atoms have just one valence electron. These are desperate. They react quickly. They give away their electron to anyone who will take it. These are the alkali metals, always looking for a bond. Others have 7 valence electrons. They are hungry, always trying to steal one more. These are the halogens. Then there are the noble gases. They have 8. They are full. They are calm. They do not react. They are happy on their own. In life, you see this too. People who are always giving, people who are always taking, and people who seem complete without anyone else. Visualize this. You are watching a game of cards. Each player has a hand. Some have too few cards. They keep grabbing more. Some have too many. They are trying to get rid of them. But there is one player with a perfect hand. They do not take. They do not give. They just sit calmly, watching. That is how valence electrons work. It is all about reaching balance. And this balance decides everything, whether something is stable or unstable, whether it is safe or dangerous, whether it will bond with others or stay alone. Valence electrons are the silent force that controls everything. They are the quiet reason behind every reaction. And they are a reminder that sometimes it is not about how much you have, but about how much you share or protect. Level 28. Lewis Structures. What does it really look like when two people are trying to connect but still holding something back? What does it mean when someone shares only parts of themselves while keeping the rest locked away? That is the story Lewis structures tell. They are drawings used to represent how atoms share their electrons. These diagrams help us understand where the connections happen and where they don't. Every dot and every line in a Lewis structure shows what is being offered and what is being kept. In real life, relationships work the same way. Everyone walks around with their own set of electrons. Some are ready to share, others are tightly held. A Lewis structure shows you which atoms are reaching out and which ones are closed off. It shows the bonds that are formed, the lone pairs that are left untouched, and the spaces where nothing ever connects. In families, workplaces, and friendships, this is visible every day. Some people are constantly offering their energy. They give their time, their emotions, their trust. Others stay silent. They hold back. And it's not always clear why. Just like lone pairs in a Lewis diagram, those parts are there, but they're not part of the connection. They exist quietly, still affecting the space around them. Understanding Lewis structures is about recognizing that connection is not just about who is present. It's about who is actually involved, who is giving, who is receiving, and who is just occupying space. These diagrams help chemists predict the shape of molecules, but they also help us understand how hidden emotions can change the shape of our lives. A molecule might look complete, but if lone pairs are ignored, the angles shift, the bonds stretch, and the whole thing feels different. That's why Lewis structures are more than drawings. They are blueprints for communication, for honesty, for vulnerability. They remind us that even if something looks full, it might still have pieces that no one sees. Level 29. Chemical Reactions. When something changes so deeply that it cannot go back to what it was, that is a chemical reaction. It is not a surface change. It is not just a different look or a new position. It is a transformation. A rearrangement of atoms that creates something entirely new. In real life, this is what happens during moments of intense emotion or crisis. A betrayal, a breakthrough, a loss. You are not the same person afterward. Something inside you shifts. Chemical reactions occur when bonds are broken and new ones are formed. Heat might be released, light might flash, gas might rise. But at the atomic level, it is just old structures falling apart and new ones forming. And it's permanent, just like how a burned bridge cannot be walked on again, just like how a lie can undo years of trust. Some reactions happen quickly, like an explosion. Others take time. They unfold quietly, like resentment building between two friends or distance growing in a marriage. And just like in chemistry, the speed of the reaction depends on pressure, temperature, concentration. In emotional terms, that means how much stress you are under, how hot the situation feels, how much has built up inside. But no reaction happens without a trigger. There must be contact, some kind of collision. Even if two substances are near each other for years, nothing happens until they interact in the right way. That is why some conversations explode after being buried for years, because the energy finally reaches the activation point, and once the reaction begins, it cannot be undone. It changes you. But not all chemical reactions are destructive. Some create water. Some release energy that keeps you alive. Some reactions give life. The key is knowing which ones are worth initiating. And understanding that every reaction has consequences. Some give off heat, some absorb it. Some happen in an instant. Some change you slowly, but none leave you untouched. Level 30. Reactants and Products. Every reaction has a beginning and an end. The reactants are what you start with. The products are what you get. But in between, something is lost and something is gained. In relationships, the reactants are the people involved, their histories, their intentions, their fears. When they interact, something new forms. Maybe love, maybe conflict, maybe a lesson, but they are not the same afterward. The products are shaped by what the reactants brought in. In chemistry, reactants combine in specific ways. You cannot throw in anything and expect a result. Just like in life, you cannot bring dishonesty into a conversation and expect clarity. You cannot bring bitterness into a friendship and expect peace. The product will reflect the ingredients. That is why understanding reactants is so important. If one is unstable, the entire reaction can fail. If one is missing, nothing happens. People often focus on outcomes. They look at the product and judge it, but they ignore the reactants, the starting materials, the cause. That is the mistake. Because if you want to change the outcome, you have to change what goes in. In a workplace, if there is conflict, look at the inputs, the pressure, the expectations, the communication. In families, if there is silence, look at the past, the unsaid words, the emotional walls. The reactants are always the root, and the products are always the result. This is true in chemistry and in life. Nothing comes from nowhere. Every product is the end of a process. Every result is the echo of a beginning. Level 31. Balancing equations. A chemical equation tells the story of a reaction, but it only makes sense if it is balanced. That means the number of atoms on the left side of the equation must be the same as on the right. You cannot lose or gain atoms, they just rearrange. This is the law of conservation of mass. In simple terms, nothing is created or destroyed, it only changes form. This applies to life in powerful ways. When something feels unfair, when something feels broken, look at the balance. What went in and what came out? Did someone give more than they received? Did one person carry all the weight while the other stood still? In a healthy relationship, the emotional equation is balanced. Both sides give, both sides receive. But when one side always adds and the other only takes, the equation becomes unstable. It stops making sense, it collapses. Balancing equations is not about perfection, it is about honesty. If one molecule of methane reacts with 2 molecules of oxygen, the products must reflect that. You cannot just add a product you like. You cannot ignore a leftover atom. In emotional terms, you cannot just expect peace if you did not give understanding. You cannot expect loyalty if you never offered trust. The inputs and outputs must match. And if they do not, the reaction fails. That is what balancing teaches. That fairness is not just a moral idea, it is a requirement. In chemistry, unbalanced equations do not work. In life, unbalanced relationships do not last. They fall apart, slowly, quietly, until one day, the reaction stops, and all that is leftover atoms. People who once gave everything but got nothing back, emotions that were never returned. That is why balancing is not just about numbers, it is about truth. End. Level 32. Endothermic Reactions. Imagine this. You are standing in front of an ancient door, cold and silent. A woman with sharp eyes and a silver cloak stands beside you. Her voice is soft but demanding. If you want to open this door, you must give something first, something precious, something warm. You hesitate, feeling the chill in the air pressing against your skin. But the door will not open without a price. You reach into your pocket and offer a small flame. Instantly, the door begins to glow. It pulls the heat from your flame, devouring it. The flame disappears, but the door swings open. This is an endothermic reaction, a process that cannot happen without taking in energy, a reaction that is not satisfied until it has absorbed something. But it does not give that energy back. It keeps it. It needs it. And without it, nothing will change. In chemistry, an endothermic reaction is a process where energy is absorbed from the surroundings. It is like a quiet thief. It does not destroy. It does not explode. It simply takes. Ice melting is an endothermic reaction. It takes heat from the air, from your hand, from anything it touches. That is why touching ice feels cold. It is stealing your warmth. But it is not just about cold things. Sometimes it is about transformation. Think of cooking an egg. You apply heat, but the egg absorbs it. It changes from liquid to solid. It cannot become what it is meant to be without taking that energy. That is the nature of endothermic reactions. They are hungry, silent. They change things by taking. But this is not just science. This is how people can be too. Think of a friend who always listens, always helps, always supports, but never gives anything back. They take your energy, your time, your warmth, and they leave you feeling cold. Or think of a relationship where you are always the one who makes the plans, who fixes the problems, who apologizes. It is an endothermic connection. It only survives by taking, and the more you give, the more it takes. But unlike the ice, this kind of endothermic bond does not melt, it just drains you, slowly, quietly, until one day you feel empty. But there is another side. Sometimes being endothermic is not about selfishness. Sometimes it is about survival. Plants are endothermic in a way. They absorb sunlight. They take in energy from the sun. Without that light, they would wither. They are not stealing. They are just surviving. Just like people who take love because they never felt it growing up. Just like someone who needs constant reassurance because they were always afraid of being left. Not all taking is cruel. Some is just a desperate search for warmth in a world that feels too cold. But here is the hidden truth. Endothermic reactions are not weak. They are powerful. They are transformations. They take, but they create. They absorb, but they change. A block of ice melts and becomes water. A cold, raw piece of meat becomes a warm, cooked meal. A lonely, desperate person can become someone strong and kind if they are given enough warmth. But they will always need it. They will always be hungry for it, just like the ancient door that only opens when it takes the flame. So the next time you feel drained, the next time you feel like someone is always taking from you, remember the endothermic reaction. It is not always wrong, but it must be balanced. Because if you keep giving and never receiving, you will burn out. You will become cold. And if you are the one who always needs warmth, remember this: the world has warmth to give. But you must learn to keep it, to hold it, to not just take it and let it escape, because nothing stays warm forever. Level 33. Exothermic Reactions. Picture this: a quiet forest on a cold night. You stand by a campfire, feeling the gentle heat on your face, but then you hear something behind you. You turn, and a figure steps out of the shadows. A tall, silent figure with dark, glowing eyes. He walks toward the fire, but instead of stepping into the light, he reaches out and touches it. And suddenly, the fire grows. It roars. It bursts with fierce, blinding heat. You step back, feeling the flames push against you. The air is alive. The cold is gone. But so is the darkness. This is an exothermic reaction. A process that releases energy. A process that cannot stay silent. It gives. It burns. It cannot hide what it is. In chemistry, an exothermic reaction is a process that releases heat into the surroundings, like a fire burning, like an explosion, like a spark that becomes a blaze. It does not wait. It does not hold back. It is energy unleashed. Think of fireworks. A tiny spark sets off a beautiful burst of light. That is an exothermic reaction. Or think of a match. One small strike, and it releases its energy as a flame. It is a reaction that cannot stay inside. It must share its heat. But this is not just about heat. It is about change. It is about the kind of reaction that spreads, that grows, that cannot be ignored. But look closer. An exothermic reaction is not always about fire. It can be about feelings too. Think of a person who cannot keep their anger inside. They burst, they shout, they break things. They are an exothermic reaction. Or think of someone who laughs so easily, who lights up a room just by being there. They are exothermic too. They do not keep their energy hidden, they share it. Sometimes they share too much. They burn too bright. They burn out. But in that moment, they are alive. They are heat. They are light. But here is where it gets dangerous. Not all exothermic reactions are beautiful. Some are violent. Think of a forest fire. One spark, and it consumes everything. Think of an argument that starts with one harsh word and becomes a storm of insults. Think of a lie that spreads until it burns every bridge. Exothermic reactions are powerful, but they are also wild. Once they start, they are hard to control. That is the secret. They are not just reactions. They are chains. One action triggers another. One feeling becomes 100. One moment of anger can become a lifetime of regret. But there is another side. Exothermic reactions can save you too. When you are cold, a fire can bring you back to life. When you are afraid, the warmth of a friend's hug can make you feel safe. When you are lost, a bright light can show you the way. Not all flames are dangerous. Not all energy is destruction. Sometimes it is comfort. Sometimes it is life. Just like the heat of the sun that keeps the world warm. Just like the warmth of a memory that makes you smile. But here is the truth. Just like the match that only burns once. Just like the fireworks that fade after a moment. Exothermic reactions are temporary. They give everything, but then they are gone. They are passion without patience. They are brightness without stability, and that is their beauty. They remind you that energy is meant to be shared, that warmth is meant to be given. But they also remind you to be careful, because what burns too bright can also burn too fast, and what feels like light can become a fire you cannot control. So when you see a fire, when you feel warmth, remember that it is not just a gift. It is a release, a giving away of energy, and every flame is a choice, to light up, to burn, or to let the darkness stay. Level 34. Law of conservation of mass. Imagine you are sitting by a quiet, calm lake. The water is still like a perfect mirror, but then someone throws a stone into it. Ripples spread, waves form. The water rises and falls. It looks like chaos, but something strange happens. No matter how wild the ripples become, the lake does not overflow. No water is lost. No water is created. It is just moved. This is the law of conservation of mass. The idea that in any closed system, mass cannot be created or destroyed. It can only change form. The total amount stays the same. This law is true for everything. When you burn wood, the wood disappears. It turns to ash, smoke, and heat. But if you collect everything, the ash, the gases, the heat energy, the total mass is still there. It has just changed. Nothing is lost. Nothing is magically created. In chemistry, this is a law you cannot break. It is the reason why chemical equations must always be balanced. Whatever you start with must equal what you end with. If you have 2 atoms of hydrogen in the beginning, you must have 2 atoms of hydrogen at the end. If you have 10 grams of a substance, you must have 10 grams in some form at the end. This is the hidden balance in everything. But this law is not just about science. It is about life. Imagine a friendship where one person always gives and the other always takes. Over time, something happens. The one who gives starts to feel empty. The one who takes becomes overwhelmed. Nothing is lost, but everything changes. Emotions do not disappear, they shift. Trust can become doubt. Love can become bitterness. Laughter can become silence. But the total energy, the total impact is still there. It is just transformed. This is why closure is so hard. You cannot just erase a memory. You can only change how it exists in your mind. Visualize this. A glass of water spills on the floor. You grab a towel and clean it up. The water is gone from the glass, but it is now in the towel. If you squeeze the towel, the water comes back. It never left. It only moved. This is the truth of everything. Even when something seems to disappear, it is still there, just in a different form. When someone leaves, the space they filled is not empty. It is filled with memories, with thoughts, with feelings. When you lose something, you do not lose its existence. You just lose its form. This is the law of conservation of mass. A reminder that nothing truly disappears. It just changes. And understanding this can change how you see loss. It can change how you see life. Level 35. Acids and bases. Listen closely. Not all substances are the same. Some are sharp, reactive, even dangerous. Others are smooth, calming, almost soothing. This is the world of acids and bases. There are 2 opposite forces that exist in nature and in life. Acids are substances that release hydrogen ions when they are in water. They are sour, they can burn, they can corrode metal. Vinegar is an acid. Lemon juice is an acid. The stomach acid in your body is an acid. These are things that can hurt, but are also essential. Without stomach acid, you could not digest your food. But too much of it can cause pain. Bases are the opposite. They are substances that release hydroxide ions when in water. They are bitter. They feel slippery. Soap is a base. Baking soda is a base. Even the cleaning products you use are often bases. They are things that feel smooth but can also be harmful. Touching a strong base can burn your skin just like an acid can. But just like acids, bases are necessary. They neutralize acids. They keep things balanced. But here is the truth. Most things are not purely acid or purely base. They are a mix. Even your blood has a balance of acid and base. Too much acid in your blood can kill you. Too much base can also be deadly. The same is true in life. Some people are like acids. Sharp, direct, sometimes hurtful, but honest. Others are like bases. Gentle, soft, but sometimes too passive, too indirect. Both are needed, and the real problem is when one becomes too strong. An overly acidic person can become cruel. An overly basic person can become fake, hiding their true feelings. Balance is the key. Visualize this. You are in a kitchen with 2 glasses of clear liquid. One is vinegar, an acid. The other is soapy water, a base. You cannot tell just by looking which is which. But the moment you taste them, the truth is clear. This is how life works too. Some people seem gentle until they speak, and their words burn. Others seem cold until they help you, and you realize they are calming. The truth of an acid or a base is not in how it looks, but in how it reacts. And there is one more truth. When an acid and a base mix, they neutralize each other. They create something new, water and a salt, something safe, something balanced. This is the power of opposites. When 2 strong but different forces meet, they can destroy each other, or they can create balance. This is why relationships can be powerful, but also dangerous. If 2 people are too similar, they may compete. If they are too different, they may fight. But if they balance each other, they can create something beautiful, like water from an acid and a base. Calm from chaos, healing from hurt. That is the lesson of acids and bases, that even the sharpest things can become soft, that even the most calming things can become harmful. And that balance is not about being the same. It is about finding harmony in differences. Level 36, pH scale. The pH scale is a simple tool that measures how acidic or basic something is. It is a line of numbers from 0 to 14. 7 is neutral, like pure water. Anything below 7 is an acid. Anything above 7 is a base. The lower the number, the stronger the acid. The higher the number, the stronger the base. A pH of 1 is like stomach acid, burning and sharp. A pH of 13 is like bleach, strong and dangerous. But in the middle, at 7, there is calm, there is balance. This scale is not just about science, it is about understanding balance. It is about measuring extremes. It is about knowing where you stand. Some people are like strong acids. They are intense, always pushing, always challenging. They can be exciting but also dangerous. Others are like strong bases. They are calm, almost too calm. They seem gentle, but they can be overwhelming in their passivity, and most people are somewhere in between. Not too sharp, not too soft, just balanced. Visualize this. You are walking along a narrow path. On one side is a burning desert, hot and dry. This is the world of acids. On the other side is a freezing ocean, cold and bitter. This is the world of bases. The path is safe, but one wrong step, and you fall into extreme heat or extreme cold. This is the pH scale. A reminder that balance is not just a choice. It is a survival skill. But there is a deeper truth. The pH of something can change. Lemon juice can become less acidic if mixed with water. Soap can become less basic if diluted. And in life, people can change too. A person who is too sharp can learn to be gentle. Someone too soft can learn to stand up for themselves. But this change does not happen on its own. It takes something new. It takes a reaction. Just like an acid and a base must mix to become neutral, a person must experience something new to find balance. The pH scale is not just a measure of chemicals. It is a guide to understanding extremes. It is a map of balance. It shows you that even the strongest things can be softened. Even the softest things can become sharp, and that somewhere in the middle is where life finds its peace. Level 37, Neutralization. Neutralization is the process where opposites meet and cancel each other out. In chemistry, This happens when an acid and a base react to form water and a salt. But it is not just about substances. It is about balance. Acids are substances that release hydrogen ions. Bases release hydroxide ions. When they combine in the right amounts, their strengths are neutralized. The result is neither too harsh nor too bitter. It becomes something safe, something stable. In real life, this is exactly how conflict resolution works. Two strong opinions, two opposing emotions. When handled correctly, they can meet in the middle. But that only works if the reaction is balanced. If one side overwhelms the other, the result is not neutral. It is just suppression. That is not resolution. That is silence pretending to be peace. Neutralization is about equal force, equal intensity, equal willingness to meet. In families, it shows up when anger is met with calm understanding. In workplaces, when stress is balanced with support. In relationships, when jealousy is met with honesty instead of control. But not every acid should be neutralized. Some are too strong. Some bases are too reactive. And sometimes you need to separate them before someone gets hurt. Chemists measure how strong or weak an acid or base is before mixing them. People often skip that step. They rush into arguments. They ignore warning signs. Then they wonder why everything exploded. Neutralization also releases energy. That moment of balance creates something new. It is not the same as before. It is transformed. In human terms, that moment of understanding, when two people really hear each other, is a release, a letting go, a change in atmosphere. The environment shifts. Something that was heavy becomes lighter. But it only works when both sides are present. When one person is already gone emotionally, there is no reaction, no neutral zone, just silence. And that silence builds more pressure. That is why understanding neutralization is so important. Because every relationship has acid moments, every job has pressure, every home has arguments. But what happens next depends on whether you bring acid or base, whether you meet it with fire or calm, and whether you walk away balanced or burned. Level 38. Redox Reactions. Redox reactions are about transfer. One substance loses electrons, another gains them. This movement of electrons is what makes the reaction work. Redox is short for reduction and oxidation. Reduction is the gain of electrons. Oxidation is the loss. They always happen together. If something is being reduced, something else must be oxidized. One cannot happen without the other. This is a rule of chemistry. It is also a rule of human interaction. Every time someone gains control, someone else loses it. Every time one person becomes more powerful, someone else becomes more vulnerable. These are not just emotional shifts. They are energetic exchanges. When a person manipulates a situation to gain attention, someone else loses their voice. When one department in a company gets more resources, another might be cut. When one sibling is constantly praised, the other might feel invisible. That is how redox reactions show up in life. They are not obvious, they are not loud, but they change everything. The electron is tiny, but when it moves, the entire identity of an atom changes. The same goes for trust, for dignity. For space, when you take something small away from someone enough times, you change who they are. You shift their chemical identity. In chemistry, oxidation often involves oxygen. That is why metals rust. Oxygen pulls electrons away from the metal. The metal loses its shine. It weakens. In people, constant pressure does the same. It pulls energy away. It creates emotional rust. Some people give and give until they are left empty. Others take and grow more powerful without even noticing the cost. But redox reactions can be used to help. Batteries are built on redox. Energy is produced by the controlled flow of electrons. That flow powers devices. It brings light. It fuels movement. In relationships, this can be healthy. A person gives support. and another grows, but only when there is a return, when the giving and taking are balanced, when reduction and oxidation are understood, not exploited. Redox reactions teach us that every gain has a cost, every loss has an effect, and when the movement is too much in one direction, something breaks. That is why people burn out, why partnerships fail. Because the transfer was never fair, redox reminds us that connection always involves exchange, and the way you manage that exchange determines whether you build something powerful or destroy something fragile. Level 39, Oxidation State. Oxidation state is a number, but it is more than that. It tells you how many electrons an atom has gained or lost in a compound. It is a way to track change. It is a label that shows how much has shifted. And just like people, atoms wear these labels whether they want to or not. When an atom loses electrons, its oxidation state becomes positive. When it gains electrons, the number becomes negative. These numbers matter. They decide how atoms behave, what they can bond with, what they can become. In life, your emotional oxidation state is how much you have given or taken. A person who has given too much without receiving becomes drained. Their energy is positive, but not in a good way. It means they are missing something. They are running on empty. A person who has taken too much might seem full of energy, but that negative charge can become unstable. It can cause reactions they do not expect. These states shift depending on the environment. Just like in chemistry, in a supportive home, a person might be balanced. In a toxic workplace, their state can change. They become reactive, defensive, even aggressive. And these changes are not always visible. You do not see the electrons move, but the behavior shifts, the bonds change, the reactions become unpredictable. That is why oxidation state is so useful. It helps chemists understand what an atom might do, who it can bond with, what reactions it might cause. In people, it helps us ask better questions, not just what someone did, but why they did it. What have they lost recently? What are they missing? What has changed in their environment? Because people do not change for no reason. Their emotional oxidation state tells the story. It shows what they are carrying, what they are hiding, what they are craving. And if we look closely enough, we can predict the reaction before it happens. That is the power of understanding oxidation states. They are not just numbers, they are signs. And if we read them well, we can prevent explosions. We can build stronger bonds. We can keep things stable before they fall apart. Level 40. Electrolysis. Electrolysis is a process where electricity is used to cause a chemical change. It is a way of breaking down a substance using an electric current. This might sound complicated, but it is actually very simple. Imagine a container filled with water, but this is not just any water. It is water with a little bit of salt in it. When you place two metal rods called electrodes into the water and connect them to a battery, something happens. Bubbles begin to form on the electrodes. The water is breaking apart. This is because the electricity is forcing a reaction. The water is splitting into hydrogen gas and oxygen gas. What was once a calm liquid is now a place of energy and change. This is electrolysis. It is the power of electricity to split things apart. But this is not just about water. Electrolysis is used in many ways. It is how pure metals are made from their ores. Copper is taken from its rocky ore using electrolysis. It is also how aluminum is made. Without electrolysis, there would be no pure aluminum for your soda cans or your airplane wings. It is how we make chlorine gas from salt, a chemical that is used in cleaning products and even in swimming pools. Visualize this. You are standing in an old workshop. The air is filled with a soft hum. In front of you is a glass container filled with a blue solution. Wires lead to a small battery, and two metal plates hang in the solution. Slowly, you see a bright green gas forming on one side. On the other side, a metal layer starts to appear. This is copper being pulled from the solution, pure and shining. It feels like magic, but it is just electricity doing what it does best. Moving electrons, breaking bonds, creating something new. Electrolysis is not just a chemical process. It is a reminder that change takes energy, that nothing breaks apart without a force. In relationships, this is true too. Sometimes a connection seems strong until a spark appears. A fight, a lie, a mistake. Suddenly everything breaks. But even then, what is lost does not disappear. It just changes. Just like the water that splits into hydrogen and oxygen. What was once one thing becomes two, but it is not destroyed. It is just transformed. Electrolysis is also a reminder that even the most stable things can be split, that even what seems complete can be broken down if enough energy is applied. It is how diamonds can be cut, how metal can be purified. It is a lesson that nothing is truly unbreakable, not even the strongest bonds, but it is also a lesson in creation, because electrolysis can also build. It can coat metals with gold or silver. It can turn salt water into pure chlorine and clean drinking water. It can take something useless and make it valuable. This is the double truth of electrolysis. It can destroy. It can create. It is all about how you use the energy. Level 41. Catalysts. Catalysts are substances that speed up a chemical reaction without being changed themselves. They are like silent helpers. They make things happen faster, easier, but they are not part of the final result. Imagine you are watching two people in a room. They are trying to talk, but they are nervous, shy, avoiding each other's eyes. Nothing happens. But then, a third person walks in. They smile, introduce the two, make a joke, and suddenly the conversation flows. The two people are talking, laughing, connecting, but the third person steps away, unnoticed. That person was a catalyst. They made the connection happen, but did not become part of it. This is how catalysts work in chemistry. In your body, enzymes are natural catalysts. They help break down your food, turn it into energy, repair your cells. Without them, your body would be slow, tired, unable to survive. In industry, catalysts are used to make things faster. They help create plastic, medicine, fuel. They save time, energy, and money, but they do not change themselves. They remain the silent helpers. But there is a deeper truth here. Catalysts are not just in chemistry, they are in life. A teacher who makes you believe in yourself is a catalyst. A friend who helps you see the truth is a catalyst. A difficult moment that forces you to become stronger is also a catalyst. They are things or people who cause change without becoming part of the change. Visualize this. You are trying to light a fire, but the wood is wet, it will not catch. Then someone hands you a small piece of dry paper, you light the paper. It burns quickly, and the wood catches fire. The paper is gone, but the fire is burning. That is a catalyst, something that makes things happen faster. And this lesson is important. Because sometimes in life, you need a catalyst. You need something to give you a push, to show you the way. But you must also remember that being a catalyst can be dangerous. Sometimes you help others and watch them grow, but they move on. They forget you, just like a catalyst that is left behind once the reaction is complete. But that does not make your role less important. In fact, it makes it powerful. Because you were the reason something happened, even if you were not part of the final story. Catalysts are also a reminder that sometimes the right help is the one that does not try to control. It is the one that simply creates a chance, an opportunity, and then steps back. It is a teacher who gives you the tools, but lets you decide. It is a friend who supports you, but lets you choose your own path. That is true strength. To help without taking control. To change without being changed. That is the silent power of a catalyst. Level 42. Activation energy. Activation energy is the minimum amount of energy needed for a reaction to start. It is like a barrier that must be crossed. Imagine you are trying to push a heavy boulder up a hill. At first, it does not move. You push harder, sweat forms on your forehead, your muscles ache, but then suddenly, the boulder begins to move, and once it starts, it rolls easily. This is how activation energy works. At the start, a reaction needs energy to begin, but once it starts, it keeps going on its own. In chemistry, this is true for everything. Lighting a match needs a spark. Once the flame begins, it keeps burning. Cooking food needs heat, but once the food is hot enough, it cooks easily. Even in your body, enzymes lower the activation energy for reactions, making life possible. Without them, your body would not have enough energy to keep going. But this idea is not just about chemistry. It is about life. Think about a new habit you want to start. Maybe you want to exercise every morning. At first, it is hard. Waking up early feels impossible. Your body is tired. Your mind is full of excuses. But if you can force yourself to do it for a few days, it becomes easier. It becomes natural. That is activation energy. The hardest part is always the start. Visualize this. You are in a cold room. You want it to be warm. You light a small fire in the fireplace. At first, the fire is weak. You have to keep adding wood, blowing on the flame. But once it catches, the room becomes warm, and you no longer need to struggle. This is the truth of activation energy. The beginning is always the hardest. But once you cross that barrier, everything becomes easier. This is why people struggle with change. It is not that they cannot do it. It is that the start seems impossible. The first step feels heavy. The first words feel awkward. The first action feels like pushing a boulder. But if you understand activation energy, you know the secret. You know that once you begin, it will get easier. It is why people fear new challenges. They see the hill but not the slope beyond it. They feel the weight but not the freedom that comes after. But understanding activation energy can change everything. It can give you patience. It can give you hope. It can remind you that every great change, every great success, begins with one difficult push. Level 43. Reaction rate. Picture this. You are sitting across from someone you love. You can see their eyes, their smile, the way they lean forward when they are interested. But there is something different. A cold distance that was never there before. You ask a question, but their response is slow, too slow. They say they are fine, but their voice lacks warmth. You try again. A joke, a memory, but nothing sparks. It feels like you are watching something fade. A connection that once burned bright, now feels like a dying ember. That is what reaction rate is. The speed at which a change happens. In chemistry, it is the speed at which reactants turn into products. But in life, it is the speed at which emotions change, at which trust is built or lost, at which understanding is gained or forgotten. A fast reaction rate means something happens instantly. Like anger rising the moment someone insults you. Like love at first sight. Like a rumor spreading in seconds. But a slow reaction rate is different. It is a friendship that fades without a fight. It is a silent resentment that grows over years. It is a relationship that ends not with a shout, but with quiet, empty spaces. And just like in chemistry, the rate of a reaction depends on the conditions. More heat, faster reaction. More pressure, faster reaction. In life, this means stress speeds up conflict. Time together deepens a bond. Silence can freeze a feeling until it disappears. Some reactions are so slow you never notice them until it is too late. You think nothing has changed. But one day you wake up and realize you do not feel the same. You do not trust the same. You do not care the same. That is why reaction rate matters, because it shows how fast something can be created or destroyed. But sometimes, it is not just about speed. Sometimes, it is about control. Catalysts are substances that speed up a reaction without being changed themselves. In life, these are the words you say, the actions you take. A single apology can heal years of hurt. A single lie can shatter trust in an instant. The right words at the right time can be a catalyst for love, for forgiveness, for understanding. But the wrong words can be a catalyst for chaos. Reaction rate is not just a science term. It is a reminder that change can be instant or slow, but it is always happening. And if you are not careful, you might lose something precious without even noticing. Level 44. Chemical Equilibrium. Imagine this. You are standing in a crowded room, but the noise is perfectly balanced. Voices rise and fall in harmony. Laughter mixes with whispers. Music plays in the background, but it does not overpower the conversation. It is peaceful. No one is too loud. No one is too quiet. That is chemical equilibrium. It is not a state of stillness. It is a state of balance, a point where two opposing processes happen at the same time. In chemistry, it means a reaction goes forward and backward at the same rate. Reactants become products, but products also become reactants. Nothing is lost. Nothing is gained. Everything just exists in a constant state of change. But this is not just science. It is life. It is the balance of giving and taking in a relationship. It is the balance of freedom and responsibility in a family. It is the balance of ambition and rest in your mind. But here is the secret. Equilibrium does not mean peace. It means balance. A balance between love and fear, between trust and doubt, between holding on and letting go. Even in a happy relationship, there are moments of misunderstanding. Even in a peaceful mind, there are thoughts of doubt. But they do not destroy the balance. They are part of it. Just like in chemistry, where products can turn back into reactants. But if something changes the balance, if one side becomes too strong, equilibrium is lost. Imagine that crowded room again. If someone starts shouting, the harmony is broken. If someone leaves, the silence becomes louder. In life, this is when jealousy overtakes trust, when anger silences understanding, when a promise is broken and the balance collapses. But there is another side. If you know how to control equilibrium, you can restore it. You can shift the balance back. You can add more of what is missing, more understanding in a fight, more time in a busy schedule, more patience in a stressful moment. Equilibrium is not about being perfect. It is about knowing that balance is always moving, that peace is not a place you reach, it is a state you create, and sometimes you must fight to keep it. Level 45. Le Chatelier's Principle. Feel this. You are holding a glass of water, perfectly full, but someone gently pushes your arm. The water tilts, rises, almost spills. Your instinct is to steady the glass, to bring it back to balance. That is Le Chatelier's principle. It is the idea that when a system at equilibrium is disturbed, it will try to restore balance. It is not a choice. It is a law. In chemistry, this means if you add more of one substance, the reaction will shift to use it. If you increase the temperature, the reaction will adjust to counter the heat. It is a natural pushback. But this is not just about atoms and molecules. It is about life. When something disturbs your peace, you instinctively try to regain it. When someone hurts you, you seek comfort. When you lose something, you search for a replacement. When you feel trapped, you crave freedom. But here is the truth. Not all reactions are restored perfectly. Sometimes you overcorrect. You give too much love to replace the one you lost. You chase distractions to escape loneliness. You become angry to hide your fear, but you are not really solving the problem. You are just shifting the imbalance. Just like in chemistry, where trying to fix one side can disrupt another. Le Chatelier's principle teaches that every action has a response. Every pressure creates resistance, and this is not just physics. It is emotional survival. In a toxic relationship, if one person becomes controlling, the other may become secretive. In a stressful job, if the pressure increases, you might become numb. This is your mind trying to protect itself, trying to balance. But balance is not always healing. Sometimes it is just hiding. That is the danger. When you get too good at restoring balance, you stop noticing what caused the disturbance. You just react, you adjust, you survive, but you never solve. Le Chatelier's principle is a reminder that peace is not the absence of disturbance. It is the ability to adapt without losing yourself. It is the strength to stay balanced without pretending that everything is fine. Because true equilibrium is not just about reacting, it is about choosing how to react. Level 46. Concentration. Concentration is not just about focus. In chemistry, concentration is a measure of how much of a substance is present in a solution. It tells you how crowded the particles are. Imagine a glass of water with a spoonful of salt. The more salt you add, the higher the concentration. But if you keep adding salt, at some point it will stop dissolving. That is the limit of concentration for that solution. Concentration is measured in different ways. The most common is molarity, which is the number of moles of a substance dissolved in 1 liter of solution. For example, a 1 molar solution of salt has 1 mole of salt particles in 1 liter of water. But concentration is not just a chemical concept. It appears everywhere. In cooking, a soup with too much spice is highly concentrated. In the air you breathe, oxygen is a gas with a concentration of around 21%. Even emotions can be concentrated. Love can be intense, or it can be weak and diluted. In history, concentrated solutions were used to preserve food, as salt prevented bacteria from growing. Understanding concentration is about seeing how much of something is packed into a space, whether it is salt in water or thoughts in your mind. Level 47. Molarity. Molarity is one of the most common ways to express concentration in chemistry. It tells us how many moles of a substance are present in 1 liter of a solution. A mole is a number that chemists use to count particles like atoms or molecules. 1 mole is a very large number, about 6 followed by 23 zeros. But using moles helps make big numbers easy to work with in chemical equations. When we say the molarity of a solution, we are saying how many moles of solute are dissolved in 1 liter of solvent. Think of molarity as a way to measure strength. If 1 liter of water contains 1 mole of salt, the molarity is 1. If it contains 2 moles of salt, the molarity is 2. The higher the molarity, the more concentrated the solution is. This helps chemists make sure they are using the right amounts of substances in reactions. It helps them predict how fast or how strong a reaction will be. It keeps experiments safe and controlled. Visualize this. You have 2 cups of water. In the first cup, you dissolve 1 teaspoon of sugar. In the second cup, you dissolve 5 teaspoons. The second cup tastes much sweeter. The molarity is higher. This is an example of how molarity affects the properties of a solution. It changes how it tastes, how it behaves, and how it reacts with other things. Molarity gives a clear numerical way to describe this. In daily life, we do not usually talk about molarity, but we still deal with the same idea. In cooking, recipes often tell us how much of an ingredient to use per cup of liquid. In medicine, a prescription might say how many milligrams of a drug are in a certain volume of liquid. These are all ways of measuring concentration, just like molarity does. In factories, especially in food or pharmaceutical industries, molarity helps maintain consistency. It ensures every batch of a product has the same strength. If the molarity is off, the product might be too weak or too strong. In relationships and emotions, molarity can be used as a metaphor. Imagine emotional effort as a solute. In a one-to-one conversation, if both people are fully engaged, the emotional molarity is high. But in a crowded situation where one person is trying to support 10 others, the emotional concentration becomes low. The value of molarity teaches us that true impact comes when energy is not just present, but focused within a set space. In chemical reactions, using the correct molarity is important. If you want a reaction to happen quickly, you use a high molarity solution. If you want it to happen slowly or gently, you use a lower molarity. This control is important for safety, for results, and for understanding the behavior of substances. Chemists often use a formula to calculate molarity. They divide the number of moles by the volume in liters. This gives them a simple way to know exactly how strong a solution is. Molarity also plays a big role in titration, a process used to find out how much of one chemical is in a solution. By using a solution with a known molarity, you can measure out how much is needed to react with another substance. This helps find unknown concentrations. It is a precise and trusted method. Molarity helps build accuracy in science. But beyond science, molarity reminds us that strength is not just about how much you have. It is about how well it is placed. You can have a lot of knowledge, but if it is not focused, it becomes confusing. You can have a lot of time, but if you do not use it well, it disappears. Molarity is about smart use of resources. It teaches that the right amount, in the right space at the right time, makes the biggest difference. It is about clarity, control, and purpose. Level 48, Avogadro's Law. What if you were told that the space you occupy, the air you breathe, the life you live is not defined by how big you are, but by how many pieces of you exist in that space? That is Avogadro's Law. It is a rule in chemistry that says equal volumes of gases at the same temperature and pressure contain the same number of particles. It does not matter what gas you have. Hydrogen, oxygen, carbon dioxide, all of them obey this rule. If they take up the same space under the same conditions, they contain the same number of particles. But this is not just about gas. It is about life. It means that your worth is not just about how much space you take up, but about how much of yourself you bring to the moment. It means that a small room filled with laughter is worth more than a mansion filled with silence. It means that a simple meal shared with someone who cares is more valuable than a banquet eaten alone. Avogadro's Law is a reminder that value is not just about size, it is about presence. Imagine two people in a conversation. One talks a lot, but says nothing. The other speaks quietly, but every word matters. Which one truly fills the space? Avogadro's Law would say that they both take up the same space, but the one who brings meaning is truly present. In chemistry, this law is used to calculate how many particles are in a given volume of gas. But in life, it is a lesson. It shows that even the smallest act can fill a room with warmth. Even a whisper can be heard when it is spoken with meaning. It teaches that presence is not just about being there. It is about being real, being honest, being fully yourself. Just like a gas that spreads to fill a space, your emotions, your thoughts, your actions spread to fill your life. But what are you filling it with? Is it empty noise, or is it something that matters? Avogadro's Law tells you that space is never empty. It is always filled with something, and you decide what that is. Level 49, Ideal Gas Law. What if you were told that everything you feel is a balance of pressure, volume, and temperature? that every moment you live can be explained by one simple equation, that is the ideal gas law. It is a formula that connects four properties of a gas: pressure, volume, temperature, and the number of particles. PV equals nRT. Pressure times volume equals the number of particles times a constant times temperature. It looks like just an equation, but it is the secret to understanding how the world works. If you increase the pressure in a sealed container, the gas inside gets more crowded, more intense, just like stress in your mind when you feel trapped. If you increase the temperature, the particles move faster, just like your thoughts racing when you are excited or anxious. If you increase the volume, the gas expands, becomes less dense. Just like you feel relief when you are given space to breathe. This law is not just about chemistry, it is about how life reacts to pressure. In a relationship, if pressure increases without enough space, it breaks. In a family, if the temperature rises with constant arguments, the bonds weaken. But if you balance the factors, everything stays stable. That is the secret of the ideal gas law. It is a rule, but it is also a warning. That too much pressure without release can destroy even the strongest bond. That too much heat without a way to cool down can turn love into anger. But it also means that even the most difficult situations can be managed if you know how to balance them, if you know when to step back, when to calm down, when to talk, and when to listen. Just like in a gas where the particles constantly move, but the system stays balanced, it is a dance, a constant adjustment, a reminder that nothing is truly still. That even in moments of silence, pressure builds. That even when you cannot see it, energy is moving, and you have a choice: to control it or to be controlled by it. Level 50. Kinetic Molecular Theory. How do you explain movement that never stops? How do you understand a world where everything is in constant motion, even when it looks still? That is the kinetic molecular theory. It is a way of understanding gases by recognizing that they are made of tiny particles in constant motion. These particles collide with each other, bounce off walls, change speed, but they never stop. They move faster at higher temperatures and slower when they are cooled. This is not just a theory, it is a mirror of life, because no matter how calm someone seems, their thoughts are always moving. Their emotions are always shifting. Even in silence, the mind is racing. Even in stillness, the heart is beating. And just like gas particles, people collide, they connect. They bounce off each other. Some encounters are gentle, a smile exchanged with a stranger, a quiet conversation with a friend. Others are violent, a heated argument, a painful breakup. But just like in a gas, every collision is a transfer of energy. A kind word can lift someone's mood, a harsh word can ruin their day, and this movement never stops. Even when you are alone, your mind collides with memories, your thoughts clash with regrets, your dreams bump against doubts. This is the kinetic reality of being human. And just like in gases, the energy you feel depends on the temperature around you. A warm, loving environment makes you feel safe. A cold, harsh place makes you feel trapped. But no matter the environment, the movement never stops. You are always thinking, always feeling, always reacting. Kinetic molecular theory teaches that stillness is an illusion. That everything is alive with motion, even if you cannot see it. That every emotion, every thought, every reaction is just another particle moving inside you. And the faster they move, the more intense you feel. That is why happiness can feel like flying, why anger can feel like fire, why loneliness can feel like freezing. It is all just energy, moving, colliding, changing, and you are the container, the space that holds it all. The question is, what will you let inside? What will you collide with? What will you hold? Because just like in a gas, you are always moving. and the energy you allow defines the life you live. Level 51. Solubility. Solubility is the quiet secret that decides whether a substance can disappear into another. It is not just about mixing. It is about a relationship between two substances where one can become a part of the other. But not everything can be dissolved. Not every solid can vanish in a liquid. Not every gas can mix perfectly in a solution. Solubility is the limit. It is the invisible line that tells you how much of one thing can blend into another before it can take no more. Think of sugar in water. At first, you can keep adding sugar, and it vanishes. The water is sweet but clear. But keep going. There is a point when the sugar stops disappearing. It begins to collect at the bottom, refusing to mix. That is the limit of solubility. But this limit is not fixed. It changes with temperature. Warm water can hold more sugar than cold water because heat gives the water molecules energy. They move faster, creating more space for the sugar to fit in. The same is true for gases. Cold soda holds more dissolved carbon dioxide, making it fizzy. But if you heat it, the gas escapes faster. That is why a warm soda goes flat. Solubility is everywhere. In the ocean, where salt is dissolved in water. In the air you breathe, where oxygen dissolves into your blood. Even in the food you eat, where flavors dissolve into your taste buds. It is the silent rule that decides what mixes and what doesn't. Level 52. Solute and Solvent. To understand solutions, you must first understand solutes and solvents. These are the two players in the process of dissolving. The solute is the one that disappears. It is the substance that breaks apart and spreads out. The sugar in your tea is a solute. The salt you sprinkle on your food is a solute. The powder you add to your protein shake is a solute. The solvent is the one that stays and holds everything. It is the one that welcomes the solute and lets it spread. Water is the most famous solvent on Earth. It is called the universal solvent because it can dissolve so many things. But water is not the only solvent. Alcohol can dissolve oils. Gasoline can dissolve grease. Even the air can be a solvent when it holds water vapor. The relationship between solute and solvent is a dance. The solute breaks apart into tiny pieces, and the solvent surrounds them. Sometimes, the solute completely disappears, becoming part of the solvent. Sometimes, it just breaks into small particles but never completely mixes, like sand in water. The amount of solute that can dissolve in a solvent depends on temperature, pressure, and the nature of both substances. Some solutes need heat to dissolve faster. Some need cold. Some need a gentle stir, and some can dissolve instantly. But in every case, the solute is the one that vanishes, and the solvent is the one that keeps it. Level 53. Solutions. A solution is what you get when a solute completely disappears in a solvent. It is a perfect blend, a mixture that looks like one thing even though it is made of two. You see solutions everywhere. The tea you drink is a solution of water and the compounds of tea leaves. The air you breathe is a solution of gases like oxygen, nitrogen, and carbon dioxide. Even the blood in your body is a solution, carrying dissolved nutrients, gases, and waste. Solutions are special because they are uniform. No matter where you look, they are the same. If you take a sip of salty water, it tastes salty everywhere. There are no lumps of salt. There are no spots where the water is plain. It is consistent, but not all solutions are liquid. There are solid solutions, like metal alloys. Steel is a solution of iron and carbon. There are even gas solutions, like the air around you. Solutions are a balance. Too much solute, and you get a mixture where the solute cannot dissolve. Too little, and the solution is weak. And some solutions are so strong that even a tiny bit of solute can be too much, like strong acids. Solutions are about harmony, about one thing accepting another completely until they become one. Level 54. Colloids and Suspensions. Not everything can form a perfect solution. Sometimes substances mix, but they do not dissolve completely. This is where colloids and suspensions come in. A colloid is a mixture where tiny particles of one substance are spread throughout another, but they do not settle. They are too small to sink, but too big to truly dissolve. Milk is a colloid. It looks smooth, but it is full of tiny fat droplets suspended in water. Fog is a colloid, where water droplets are suspended in the air. Even whipped cream is a colloid, with tiny air bubbles trapped in a thick liquid. Colloids are stable. They do not separate easily, but suspensions are different. They are unstable mixtures where the particles are larger, and they do settle over time. Muddy water is a suspension. Shake it, and the dirt spreads out, but leave it, and the dirt settles at the bottom. Orange juice with pulp is a suspension. You need to shake it because the pulp settles. Colloids and suspensions are the world's way of showing you that not everything can mix perfectly. Some things cling together, forming tiny clusters. Some things refuse to blend and wait for a chance to separate, but both are a reminder that mixing is not always about disappearing. Sometimes it is about floating, holding, and waiting. Level 55. Osmosis. Osmosis is a simple but powerful idea. It is the way water moves through a thin barrier, traveling from a place where there is a lot of water to a place where there is less. Imagine a cell in your body. It is surrounded by a thin, soft membrane. This membrane is like a gate, but it is a very special gate. It only lets water pass through, nothing else. This is how osmosis works. Water always moves to the place where there is less water until both sides are balanced. Think of it like this. You have two glasses. One has plain water. The other has water mixed with sugar. If these glasses were connected by a tiny tube that only allowed water to move, you would see something amazing. The plain water would start to move into the sugary water. But why? Because the sugary water has less free water. The water is attracted to balance itself. This is osmosis. Your cells use this all the time. When you drink water, it moves into your cells by osmosis. When you eat salty food, water moves out of your cells, making you feel thirsty. Even plants use osmosis. The roots of a plant draw water from the soil through osmosis. The water moves from the soil, where there is more of it, into the plant, where there is less. That is how a plant stays alive and fresh. Without osmosis, there would be no way for your cells to balance water. It is a quiet, constant process that keeps you alive. Level 56. Diffusion. Diffusion is a simple idea that is happening around you all the time. It is how particles spread from an area of high concentration to an area of low concentration. Imagine you spray perfume in one corner of a room. At first, the smell is strong only in that corner, but slowly, the smell spreads. It moves through the air, reaching every part of the room. That is diffusion. It is how particles naturally move, trying to spread out evenly. Your body uses diffusion too. When you breathe in, oxygen moves from your lungs into your blood. Why? Because there is more oxygen in your lungs than in your blood. The oxygen spreads out, balancing itself. The same happens with carbon dioxide. Your blood carries it from your cells to your lungs because there is more carbon dioxide in your blood than in your lungs. That is diffusion. Even cooking is a perfect example. When you put a spoonful of sugar in water, it slowly spreads out, making the whole water sweet. No one is stirring it, but it still spreads. That is diffusion. It is the reason the smell of fresh bread fills a bakery. It is the reason you can taste the salt when you put a pinch in soup. Diffusion is the quiet balancing of everything. It is the universe trying to keep everything spread out and balanced. Level 57. Crystallization. Crystallization is the beautiful process where a substance turns into a solid form with a unique pattern. You have seen it many times without even realizing it. Snowflakes are tiny crystals. Salt is made of crystals. Even sugar is a type of crystal. But how does this happen? Crystallization begins when a substance, like salt, is dissolved in water. When the water evaporates, the salt is left behind. But it does not just appear randomly. It starts to arrange itself in a very special, repeating pattern. That is what makes it a crystal. The molecules find a way to lock together perfectly. Think about a cave where water drips from the ceiling for years. Each drop leaves behind a tiny bit of minerals. Slowly, these minerals build up, creating stunning crystal structures called stalactites and stalagmites. This is crystallization in action. Even your kitchen can show you this. If you boil water with a lot of sugar and then let it cool, you will see sugar crystals form. They grow like tiny diamonds. Crystallization is nature's way of creating order. It is a slow, patient process that can turn something simple into something beautiful. It is how rocks form. It is how gemstones are made. It is how snowflakes fall in perfect shapes. Crystallization is nature's quiet art. Level 58. Polarity. Polarity is a concept that helps us understand why some things mix and others do not. It is all about how molecules are charged. Some molecules have a slight positive charge on one side and a slight negative charge on the other. This is polarity. Imagine a magnet. One side pulls and the other side pushes. That is how polarity works at a tiny level. Water is the best example of polarity. Water molecules have a slight positive side and a slight negative side. This is why water can mix with many things, like salt or sugar. These substances are also polar, so they are pulled apart by water. But oil is different. Oil is nonpolar. It does not have positive or negative sides. This is why oil and water never mix. No matter how hard you shake them, they will separate again. Polarity is not just about liquids. It is how your cells communicate. It is how your brain sends signals. It is how electricity flows. Even your emotions can have a kind of polarity. Think about how you are drawn to some people and pushed away from others. That is a form of polarity too. Understanding polarity helps you understand the world around you. It is why you can wash away dirt with water, but cannot wash away oil without soap. It is why magnets work. It is why the Earth has a magnetic field. Polarity is the quiet force that pulls and pushes, connecting or separating everything. Level 59. Hydrogen bonding. What if the warmth you feel when someone touches you is not just heat, but a force trying to pull two lives together? What if the way you trust a stranger with your secrets, the way you feel safe with someone you barely know, is not an accident, but a bond, just like water clings to water? Hydrogen bonding is not just a concept, it is a hidden connection, a silent force that brings two things closer without making them one. Think of a beautiful girl sitting beside a stranger in a quiet library. She drops her pen, and he picks it up. Their fingers brush against each other, and for a second, it feels like more than just a touch. A connection forms, not because they know each other, but because something in the air, something invisible, pulls them together. Hydrogen bonds are not as strong as real bonds, just like a glance or a touch is not as strong as true love, but they are enough to make something feel real. It is the reason a drop of water clings to another drop, why tears stay on your cheek without falling. It is a force of gentle attachment, a whisper that says, stay, but hydrogen bonding is also a reminder of fragility. It is a connection that can be broken by heat, by a simple shake, or a change in pressure. The girl might smile, The boy might look away, and just like that, the bond disappears. Hydrogen bonds are the bonds of almost, the touch of what could be, the taste of something you never truly had. Level 60. Van der Waals Forces. Have you ever felt someone's presence even when they were not touching you? Like sitting next to someone on a crowded train, where your arms never touch but you can feel their warmth, their breath, their inner so close, yet never connecting. That is Van der Waals Forces. It is the whisper of an attraction that is too weak to become a real connection, but it is there. It is the reason a gecko can climb a smooth wall, not because it is strong, but because millions of tiny hairs on its feet brush against the surface, creating a grip through a force so faint that it is almost a ghost. But Van der Waals Forces are not just about tiny creatures. They are about the way two people can sit in silence, two strangers in a cafe who never speak, but somehow, in the silence, there is a sense of closeness, a presence that lingers. It is why you can feel someone's gaze on your back, even without seeing them. It is the energy that fills a room when someone walks in, the tension that hovers between two people who almost touched, almost spoke. Van der Waals Forces are the forces of presence without contact, the pull of something that almost exists but never becomes real. Level 61. Intermolecular Forces. What if love is just a force, a pull between two souls trying to stay together in a world that keeps trying to pull them apart? What if every connection you have ever felt was not a choice, but a force that drew you close? Intermolecular forces are the silent pulls that hold everything together, even when everything else tries to tear them apart. Imagine a girl standing on a bridge in the rain. Her umbrella slips from her hand and starts to fly away, but a boy walking by catches it. Their eyes meet, he hands it back, and they smile. They may never see each other again, but for that one moment they were connected, pulled together by chance, by fate, or maybe just by a simple force. Intermolecular forces are the reasons why things stick together, why water forms drops, why your tears do not scatter like dust, but hold together as a single drop. But they are also the reason things fall apart when the force is too weak. The girl walks away, the boy disappears into the crowd, the bond is gone, but the memory stays. Intermolecular forces are the forces of connection, the touch that can hold or slip, the moment that means everything or nothing. Level 62. Lattice Structure. Imagine a kingdom where everyone is connected, each person standing in perfect formation, their lives neatly arranged like a beautiful pattern. That is a lattice structure. It is a perfect order, a crystal world where every piece has its place, and nothing can exist without the other. Think of a beautiful crystal, so perfect and sharp that it can cut you. Each piece is locked in place, held by bonds so strong that they cannot be broken without shattering everything. But lattice structures are not just about crystals. They are about families that never change, traditions that never break, people who are trapped in roles they never chose. Like a boy born into a family of warriors, forced to fight, to be strong, to never show fear. He is part of a structure, and his place is decided. Or a girl whose parents expect her to be perfect, to follow their dreams instead of her own. Lattice structures are prisons made of perfection, worlds where everyone has a place, but no one is truly free. It is beauty that comes with a cost, strength that never bends, a bond that never lets go, even when it should. Level 63. Allotropes. Allotropes are a hidden secret of matter. They are different forms of the same element, like a person with many faces. They are proof that the same thing can exist in completely different ways, looking and acting like something else. But the truth is always there, hidden beneath the surface. Think of carbon. Carbon is one of the most common elements in the universe. It is in your body, in the air you breathe, in the food you eat. But carbon is a master of disguise. It can appear as a soft black powder called graphite, which you use in pencils. It is smooth and slippery, perfect for making marks on paper. But that same carbon can also become diamond. Hard, clear, sparkling diamond, which is one of the hardest materials on Earth. Both graphite and diamond are pure carbon. They are made of the same atoms, but their atoms are arranged differently. In graphite, the carbon atoms are in flat sheets that slide over each other. In diamond, they are locked in a strong, three-dimensional network. This difference in arrangement is what makes one form soft and the other incredibly hard. Carbon has another face too, the buckyball, which is a tiny spherical cage of carbon atoms. It looks like a tiny soccer ball at the atomic level. And then there is graphene, a single layer of carbon atoms arranged in a honeycomb pattern. It is one of the strongest and lightest materials ever discovered. One element, many faces, that is the power of allotropes. But carbon is not alone. Oxygen has its own allotropes. There is the oxygen you breathe, which is made of two oxygen atoms bonded together. But there is another form of oxygen called ozone. It is made of three oxygen atoms. Ozone is a gas that protects you from the sun's dangerous ultraviolet rays. But it can also be harmful if you breathe it in too much. It is the same oxygen, just arranged differently. Even phosphorus has allotropes. There is white phosphorus, which is so reactive it can catch fire in air. And there is red phosphorus, which is more stable and is used in matches. And then there is black phosphorus, which is even more stable and looks like a dark, shiny crystal. These are not different substances. They are the same element, showing different personalities. It is a reminder that even in science, identity is not always simple. The same thing can appear in many ways, depending on how its atoms are connected. Allotropes are a story of transformation. They show you that even the most basic, pure elements are not one thing. They can change. They can become something new without ever becoming something else. They are a mystery hidden in plain sight. You can hold a pencil made of graphite in one hand and a diamond in the other. Both are carbon, but one is fragile and the other is nearly indestructible. And it is not just carbon or oxygen. Sulfur has allotropes. One is a bright yellow, crumbly solid. Another is a clear, amber-like crystal. Tin has allotropes too. At low temperatures, it turns into a gray, powdery form called gray tin. But at room temperature, it is a shiny metallic solid. Even iron has hidden faces. When it is heated and cooled in different ways, it can become soft, flexible iron or hard, brittle cast iron. Allotropes teach you that even the simplest things can have complexity. They show you that identity is more than just a name. It is about the structure, the arrangement, the hidden connections. The same atoms can become something new with just a change in how they hold each other. And it is not just a scientific idea. It is a reflection of life. The same person can be kind or cruel, strong or weak, brave or afraid. It all depends on how they are shaped by their experiences, their choices, their connections. Just like carbon can be a soft, dark graphite or a sparkling, clear diamond, you can become many things. The question is, which form will you take? Will you be fragile or will you be strong? Will you hide in the shadows, or will you shine with brilliance? Because in the end, the same atoms that can make a simple, soft pencil can also make a diamond that lasts forever. And that is the mystery of allotropes. Level 64. Carbon Chemistry. What if I told you that almost everything you touch, taste, or even love is made of one single tiny element? Would you believe that your own body, the food you eat, the air you breathe, and even the diamonds in the richest jewelry stores all come from the same basic building block, That element is carbon. Carbon is not just any element, it is the backbone of life. It is the most versatile element in the universe. But why is it so special? It is because carbon can connect. It can connect to itself, forming chains, rings, and vast networks. It can also connect to almost every other element, creating millions of different substances. Carbon is the reason you can have something as soft as a flower petal and something as strong as a diamond. The secret is in how carbon bonds. In your body, carbon connects with hydrogen, oxygen, and nitrogen to form proteins, fats, and even your DNA. Every time you eat an apple, drink water, or breathe in fresh air, you are interacting with carbon in some form. Carbon is not just in living things, it is in the world around you. The fuel that powers your car is made of carbon. The plastic that wraps your food is made of carbon. Even the graphite in your pencil, the very thing you use to write, is a form of carbon. And yet, this tiny element has a dark side too. Carbon is the key to life, but it can also be a cause of destruction. When carbon is burned in fuels, it releases carbon dioxide, a gas that traps heat in our planet's atmosphere. This is how carbon becomes part of climate change. But carbon is not just about pollution. It is a story of transformation. Think of a lump of coal, dark, dirty, and rough. But put it under extreme heat and pressure, and that same carbon becomes a diamond, the hardest, most precious gemstone in the world. It is still carbon, just in a different form. This is the magic of carbon chemistry. It is not just a science, it is a story of change, connection, and survival. Even ancient people knew about the power of carbon. They used charcoal to draw on cave walls, leaving behind stories that still exist today. In modern times, carbon is everywhere. It is in the gasoline you use, the food you eat, the clothes you wear, and even in the medicines that save lives. But the most powerful place you will find carbon is within yourself. Your body is made of carbon. Your thoughts are powered by carbon in the form of energy. Every breath you take is part of a carbon cycle that has been going on for millions of years. This is why carbon is not just an element. It is a connection. It connects you to every living thing on this planet. It connects you to the stars in the sky, because they are made of carbon too. And it connects you to the past and the future. Carbon is the ink of life. It writes your story every moment, even when you are not paying attention. Understanding carbon chemistry is not just about science. It is about understanding what you are made of, and what everything around you is made of. It is about understanding that even though you may feel separate, you are always connected. Because everything that is alive, or ever was alive, is made of carbon, and that means you are a part of this endless story of life. Level 65. Organic Compounds. Organic compounds are the foundation of life. They are everywhere around you, from the food you eat to the clothes you wear, from the air you breathe to the cells in your body. But what exactly makes a compound organic? It all starts with carbon. Carbon is a unique element because it has the ability to form 4 strong bonds with other atoms. This allows it to create long, complex chains, rings, and branches. These chains of carbon atoms can connect with hydrogen, oxygen, nitrogen, sulfur, and many other elements, creating a limitless variety of compounds. To truly understand organic compounds, picture this. You are sitting at a wooden table, and in front of you is an apple. The apple is a living object, filled with organic compounds. The sweetness of the apple comes from sugars like glucose and fructose, both of which are organic compounds. The crisp, fresh texture is because of cellulose, another organic compound. Even the aroma you smell is due to a combination of organic compounds that give the apple its unique fragrance. But organic compounds are not just in food. Look at your own body. Your skin, your hair, your muscles, and even your thoughts depend on organic compounds. Proteins, which make up your muscles, are long chains of amino acids, which are organic compounds. Your DNA, the code that makes you who you are, is an organic compound. Even the air you breathe contains carbon dioxide, which is a simple organic compound. It is the constant exchange of organic compounds that keeps you alive. Throughout history, humans have been fascinated by organic compounds. In ancient times, they used plant extracts for medicine, which were nothing but complex mixtures of organic compounds. The discovery of alcohol, a simple organic compound, changed human history, becoming a part of cultures and rituals. In the 19th century, the understanding of organic compounds changed forever when scientists learned how to create synthetic organic compounds in laboratories. This led to the creation of plastics, fuels, medicines, and countless other materials that now shape modern life. But organic compounds are not just a scientific concept. They are part of your daily life, shaping your experiences, your memories, and even your emotions. When you smell the perfume of a loved one, that scent is a complex blend of organic compounds designed to trigger memories and feelings. When you eat your favorite meal, the taste is a result of organic compounds interacting with your senses. When you feel energized or tired, it is because of organic compounds in your body that control your metabolism. Organic compounds are the quiet, invisible builders of life. They connect the living and the non-living, the simple and the complex. They are the reason you can see, smell, taste, touch, and feel. Every moment of your life is touched by organic compounds, even if you never see them. They are the threads that weave together the fabric of existence itself. Level 66. Hydrocarbons. Hydrocarbons are the hidden backbone of the world you live in. They are the simplest compounds made of just two elements, carbon and hydrogen. But do not be fooled by their simplicity. Hydrocarbons are the reason you have fuel for your cars, heat for your homes, and even plastic for your everyday life. They are the invisible force that powers your world. But what are they really? Hydrocarbons are molecules where carbon atoms form chains, and each carbon is surrounded by hydrogen atoms. But these chains can take many shapes. Some are straight and simple, like a row of people holding hands. Some are branched, twisting in different directions. Some even form closed rings like a circle of people. But the real power of hydrocarbons is in how they can change. When you burn them, they release energy. That is why gasoline can power an engine. It is a liquid hydrocarbon that burns and releases heat and motion. But hydrocarbons are not just for burning. They are the starting point for making plastics, medicines, and even the chemicals in perfumes. They are everywhere. Even the food you eat is made of hydrocarbons. The fats in your body are just long hydrocarbon chains, but not all hydrocarbons are the same. Some are clean and safe, like the ones in cooking gas. Others are dangerous, like the ones in cigarette smoke. Hydrocarbons are a reminder that even the simplest things can have the power to build or destroy. Level 67. Alkanes, alkenes, alkynes. Hydrocarbons are not just one thing. They are a family with different personalities. And the three most important members of this family are alkanes, alkenes, and alkynes. Alkanes are the simplest. They are the calm, stable ones. Their carbon atoms are connected by single bonds, like a strong, steady handshake. This makes them less reactive. They are the kind of hydrocarbons you find in cooking gas, in the fuel you use for heating, and in the oil you use for machines. They are safe and reliable. But then there are alkenes. These are the more active ones. They have a double bond between two carbon atoms, which makes them more reactive. Alkenes are the ones you use to make plastic. They are the building blocks of the world of synthetic materials. They are like people with a secret passion, ready to react and create something new. And finally, there are alkynes. These are the most intense, the most reactive. They have a triple bond between two carbon atoms. That triple bond is like a tightly wound spring, ready to release energy. Alkynes are used in welding torches because they burn with an incredibly hot flame. They are powerful, but they must be handled with care. These three types of hydrocarbons are like a family with three different temperaments. Alkanes are the calm and steady ones. Alkenes are the creative, reactive ones. Alkynes are the intense, dangerous ones. But they are all just different faces of the same thing, carbon and hydrogen connected in different ways. Level 68. Functional groups. Hydrocarbons are the foundation, but they can be transformed, and this transformation happens because of functional groups. A functional group is like a special badge that changes the behavior of a molecule. It is a small group of atoms added to a hydrocarbon that gives it new powers, new properties. Imagine you have a simple chain of carbon and hydrogen. It is a hydrocarbon. But if you attach an oxygen atom and a hydrogen atom to it, you now have an alcohol. That tiny change makes it something completely different. It can mix with water. It can burn in a different way. It can be used in medicines or drinks. Functional groups are what make chemistry powerful. They are the secret that turns a boring molecule into something with purpose. Add a carbon double bond to an oxygen, and you have a carbonyl group, which is found in flavors and fragrances. Add a nitrogen, and you get an amine, which is found in proteins and medicines. Add an OH group, and you get an alcohol, which can be a drink or a disinfectant. These small changes mean everything. They decide whether a molecule is sweet or sour, safe or dangerous, solid or liquid. They decide whether something can heal you or harm you. They are the switches that control the behavior of chemicals. Functional groups are the reason the world of chemistry is not just about simple carbon chains. They are the keys that unlock a world of possibilities. Level 69. Alcohols. Alcohols are one of the most well-known groups of chemicals in the world. But alcohol is not just a drink. It is a whole class of compounds that are defined by one thing. They have an OH group. This tiny group of one oxygen and one hydrogen is what makes an alcohol. But alcohols are not all the same. The alcohol you drink is called ethanol. It is the one that makes you feel relaxed, warm, and sometimes even a little foolish. It is the alcohol in beer, wine, and spirits. But there are other alcohols that you should never drink. Methanol is one of them. It is a simple alcohol, but it is deadly. Just a small amount can cause blindness or even death. It is used in industrial processes, not in drinks. Then there is isopropyl alcohol, which is used as a disinfectant. You see it in hand sanitizers, in medical wipes, in cleaning products. Alcohols can be safe, they can be deadly, they can be healing, but they are all part of the same family because of that OH group. Alcohols can also be used in perfumes, in medicines, in fuel. They are everywhere. They are a reminder that a tiny change, one small group of atoms, can turn a simple hydrocarbon into something with power. Whether that power is good or bad depends on how it is used. Level 70. Ethers. Ethers are the quiet, mysterious cousins of alcohols. They are made when two carbon chains are connected by an oxygen atom. That is it. Just one oxygen atom in the middle, and you have an ether. But this small change makes a big difference. Ethers are not like alcohols. They do not mix well with water. They are not as reactive. But they are incredibly useful. In the past, ethers were used as anesthesia. They could make you fall asleep during surgery. They were the first surgical anesthetics. But they are not used for that anymore because they are too dangerous. They are too flammable, too unstable. But ethers are still important. They are used in perfumes because they can dissolve fragrant oils. They are used in industrial processes, in fuel additives, in making medicines. Ethers are a reminder that chemistry is full of surprises. The same oxygen that can make an alcohol can also create an ether. The same atoms, just connected in a different way, can change everything. Ethers are the silent ones. They do not react easily. They do not make you feel anything right away. But they are there, holding molecules together, carrying fragrances, creating complex chemicals. They are a reminder that even in chemistry, there are quiet forces that have great power. Ethers are the bridge between molecules, the hidden connections that make things work. Level 71. Carboxylic Acids. What if something could be both sour and dangerous? What if a single type of molecule could be found in the sweet taste of vinegar and the burning sting of an ant's bite? That is the power of carboxylic acids. Carboxylic acids are a group of compounds that have a unique structure. They have a special group of atoms called the carboxyl group, which gives them their name. This group is a combination of carbon, oxygen, and hydrogen, but this tiny combination can create so many different substances. Think of vinegar. The sharp, sour taste you get when you dip your fries in it comes from acetic acid, a simple type of carboxylic acid. But not all carboxylic acids are so gentle. Formic acid is a carboxylic acid found in the sting of ants and some plants. When an ant bites you, it injects formic acid, causing a sharp, burning pain. But there is more. Carboxylic acids are in your body too. They help build important compounds like fatty acids, which are part of your cells. Even the smell of a rotten apple comes from a type of carboxylic acid called butyric acid. It is a world of tiny, powerful molecules that can be sweet, sour, or even painful. Carboxylic acids are everywhere. They are in the food you eat, the smells you love or hate, and even in the medicines that heal you. They are the silent workers of nature, creating flavors, smells, and even life itself. Level 72. Esters. Imagine a room filled with the sweet smell of fresh flowers, fruity perfumes, and ripe apples. What if I told you that this entire world of fragrances comes from one type of compound? These are esters. Esters are the reason you smell the sweetness of a fresh orange or the floral scent of a rose. They are created when a carboxylic acid reacts with an alcohol. The result is something magical, a compound with a beautiful aroma. But esters are not just about perfumes. They are in your body too. Your body uses esters to store energy and fat. Every time you eat something oily, you are tasting the hidden power of esters. In the natural world, esters are everywhere. They give fruits their fresh smell. The scent of a ripe banana, the sharp sweetness of pineapple, and the gentle fragrance of an apple are all created by esters. But they are also used in the lab. Synthetic esters are used to make artificial flavors and perfumes. The sweet smell of a strawberry candy is not always from strawberries. It is from a carefully made ester that smells just like the real thing. Esters are nature's perfumes. They are the invisible artists that paint the air with smells, making your world a little sweeter, a little fresher, and sometimes a little magical. Level 73. Amines and Amides. What if a single molecule could make you feel joy, pain, or even fear? What if it could change the way you think, the way you love, or the way you dream? That is the world of amines and amides. These are compounds that contain nitrogen, and they are everywhere in life. Amines are the key players in your body's messaging system. When you feel happy, that is because of a type of amine called serotonin. When you are in love, your brain is flooded with dopamine, another type of amine. But amines are not just about emotions. They are in the food you eat, the medicines you take, and the smells around you. The sharp, strong smell of a fish is because of amines. Even the strength of pepper has a touch of amines. Amides, on the other hand, are different. They are the strong, stable form of amines. Your body uses them to build proteins which make up your muscles, skin, and hair. Even the painkiller you take for a headache might be an amide. These are compounds that connect life and feeling. They can be a gentle hug from your body, like the calm of serotonin, or they can be a sharp sting, like the smell of spoiled fish. Amines and amides are the silent voices of your body, speaking in the language of chemistry. Level 74. Aromatic Compounds. What if I told you that the sweet smell of flowers, the smoky scent of burning wood, and the addictive aroma of fresh coffee all have something in common? These are all connected by aromatic compounds. Aromatic compounds are not just about smell, though they are often associated with it. They are a special group of compounds with a unique, ring-shaped structure. This structure makes them very stable and very useful. One of the most famous aromatic compounds is benzene. It is a ring of 6 carbon atoms, connected in a way that makes it both strong and flexible. But benzene is just the beginning. From this single ring, nature has created a world of fragrances. The scent of vanilla comes from an aromatic compound called vanillin. The fresh smell of mint is from menthol, another aromatic compound. Even the feeling of relief you get from an aspirin is because of an aromatic compound called salicylic acid. But aromatic compounds are not always gentle. Some of them are toxic. Benzene itself is dangerous if you breathe too much of it. Some aromatic compounds can cause cancer. They are a double-edged sword, bringing beauty and danger. They are the hidden magic in perfumes, the strength in medicines, and the danger in pollution. Aromatic compounds are nature's storytellers, bringing sweet memories or sharp warnings with every breath. Level 75. Isomerism. Have you ever looked at two things that look exactly the same, but are completely different? Imagine two keys. They look the same at first glance, but only one can open the door. That is what isomerism is in chemistry. It is when two compounds have the same number and type of atoms, but are arranged differently. This tiny change in structure can create a completely different substance. Think of glucose and fructose. They are both sugars made of the same atoms, but they taste different and behave differently in your body. That is because their atoms are arranged differently. There are different types of isomerism. Structural isomers are compounds with the same formula but different structures. Think of two houses made of the same number of bricks but arranged in a different way. Geometric isomers are compounds that look the same but have a different arrangement in space. It is like a mirror image. Even your own hands are an example. They look the same, but your left hand cannot fit perfectly into a right glove. This is called stereoisomerism. Isomerism is not just a trick of nature, it is a secret code. The difference between a life-saving medicine and a dangerous poison can be just a slight change in how the atoms are arranged. Understanding isomerism is like learning to read this secret code. It is a reminder that in the world of chemistry, even the smallest change can make a world of difference. Level 76. Stereoisomers. Stereoisomers are compounds that have the same chemical formula but are arranged differently in space. Think of them as two identical twins who look alike but have opposite personalities. Even though their chemical structure is the same, the way their atoms are arranged in space makes them different. This difference can be simple, like the left and right sides of your hands. You cannot place your left hand perfectly over your right because they are mirror images of each other. That is what stereoisomers are: molecules that are mirror images but not identical. Imagine this. A doctor prescribes a medicine to a patient. The medicine is supposed to relieve pain, but instead, it causes severe side effects. The reason? The medicine contained the wrong stereoisomer. One form of the compound was helpful, but the mirror image was harmful. This is why stereoisomers matter. In the world of chemistry, the tiniest change in shape can mean the difference between healing and harm. Level 77. Polymerization. Polymerization is the process of creating large molecules, called polymers, by joining smaller molecules called monomers. It is like connecting tiny beads to form a long necklace. But in the world of chemistry, these beads can be any sugar molecules that become starch, tiny gas molecules that turn into plastic, or even proteins in your body. Polymerization is everywhere around you. The rubber in your shoes, the plastic in your water bottle, and even the proteins in your muscles are all the result of polymerization. Visualize this. You are sitting in a workshop, watching an artist take tiny colorful beads and thread them together one after another. Each bead is small and seems insignificant, but as they connect, they become a beautiful necklace. That is polymerization, tiny molecules joining together to form something bigger and stronger. It is why silk is smooth, why cotton is soft, and why synthetic fibers are strong. Level 78. Biochemistry. Biochemistry is the study of chemical processes in living things. It is where chemistry meets life. It is the reason your heart beats, your lungs breathe, and your brain thinks. Biochemistry is the silent orchestra that keeps you alive, with every cell in your body playing a part. It explains how your body takes in food, breaks it down for energy, and uses that energy to keep you alive. Imagine your body as a city, and biochemistry is the network of roads, power lines, and communication systems that keep everything running. When you eat a piece of bread, biochemistry is the process that turns it into energy. When you breathe in oxygen, biochemistry is how your blood takes it to your cells. It is how your muscles move, how your eyes see, and even how your thoughts form. Level 79. Enzymes. Enzymes are proteins that speed up chemical reactions in your body without being used up. They are like tiny workers who help build, break, or transform other molecules without changing themselves. Without enzymes, most chemical reactions in your body would be too slow to keep you alive. Picture this. You are at a factory, watching a group of workers who can build a car in seconds. They do not get tired, they do not slow down, and they do not change. They just keep working. Those workers are like enzymes. They help reactions happen faster, whether it is digesting your food, repairing your cells, or creating energy. Without enzymes, life would be like a factory. With no workers, nothing would ever get done. Level 80. Proteins. Proteins are the workers of life. They are not just part of your body. They are the reason your body works. They are everywhere inside you. They are the enzymes that digest your food. They are the antibodies that protect you from infections. They are the muscles that move your body. They are the tiny machines inside your cells that build, repair, and maintain everything you are. But what are proteins really? They are long chains of tiny units called amino acids. Think of amino acids as tiny building blocks. There are 20 different kinds of these blocks, and they can be arranged in any order. When you connect them, they fold into complex shapes, and that shape decides what they do. Some proteins are strong and rigid, like the collagen in your skin and bones. Some are flexible, like the myosin in your muscles. Some are tiny tools that speed up chemical reactions, like enzymes that help you digest food in seconds. But proteins are not just made for your body. They are in everything you eat. The meat, the eggs, the beans, the nuts, these are all protein sources. When you eat them, your body breaks them down into amino acids and then rebuilds them into new proteins. Your body is a factory, constantly breaking down old proteins and building new ones. If you do not get enough protein, your body starts breaking down your muscles to get the amino acids it needs. Proteins are not just food, they are life. They are the language your body uses to work, to heal, to grow. Without them, you are nothing but a collection of empty cells. Level 81. Lipids. Lipids are the silent energy banks of your body. They are the fats and oils that keep you alive. But they are not just a source of energy, they are also the protective layers that surround your cells. They are the padding that keeps your organs safe. They are the insulation that keeps you warm. But lipids have a bad reputation. People think of them as unhealthy, as something to avoid. But that is not the whole story. Lipids are not just the fat on your body. They are in every cell of your body. Your cell membranes are made of lipids. Without them, your cells would fall apart. There are different types of lipids. There are triglycerides, which are the main form of fat in your body. They are stored in fat cells, waiting to be used as energy when you need them. There are phospholipids, which are the building blocks of your cell membranes. They form a double layer that protects your cells. And then there are steroids, like cholesterol, which is needed to make hormones. Lipids are like a savings account. When you eat too much, your body stores the extra energy as fat. When you do not eat enough, your body uses that stored fat to keep you going. But like any savings account, too much can be a problem. If you store too much fat, it can cause health problems like obesity and heart disease. Lipids are not the enemy. They are your backup plan, your protection, your hidden energy. But they must be balanced. Too little, and your body cannot survive. Too much, and your body struggles. Level 82. Carbohydrates. Carbohydrates are the fuel of life. They are the first source of energy your body uses. When you eat bread, rice, fruits, or sweets, you are eating carbohydrates. But they are not just sugar. They are a whole family of compounds that can be simple or complex. Simple carbohydrates are sugars. These are the ones that give you quick energy. When you eat candy, your blood sugar goes up quickly. But then it drops just as fast, leaving you tired and hungry again. Complex carbohydrates are different. They are made of long chains of sugar molecules, like starches in potatoes, pasta, and whole grains. They take longer to break down, giving you a steady supply of energy. But carbohydrates are not just about energy. They are also the fiber that keeps your digestion healthy. Fiber is a type of carbohydrate that you cannot digest, but it helps your body in many ways. It keeps you full. It keeps your digestion smooth. It helps control your blood sugar. Carbohydrates are the easiest form of energy for your body. When you eat them, your body breaks them down into glucose, which is used by your cells to create energy. But too much can be dangerous. When you eat more carbohydrates than your body needs, it turns them into fat. That is why eating too many sugary foods can lead to weight gain. Carbohydrates are a tool. They are your body's quick energy, but only if you control them. Level 83. Nucleic Acids. Nucleic acids are the blueprints of life. They are the molecules that carry your genetic information, the instructions that make you who you are. There are two main types of nucleic acids, DNA and RNA. DNA is the one that holds your genetic code. It is the master plan, the library of instructions for building and maintaining your body. It is found in the nucleus of your cells, where it is protected. It is a long, twisted ladder, a double helix made of smaller units called nucleotides. Each nucleotide is made of 3 parts, a sugar, a phosphate, and a nitrogen base. There are 4 types of nitrogen bases: adenine, thymine, cytosine, and guanine. And these bases pair up in a very specific way. Adenine always pairs with thymine. Cytosine always pairs with guanine. This is the code of life. But DNA does not work alone. It needs RNA to help. RNA is like a messenger. It takes the instructions from DNA and delivers them to the part of the cell that makes proteins. RNA is similar to DNA, but it is single-stranded, and instead of thymine, it uses uracil. Together, DNA and RNA are the reason you have your hair color, your eye color, your height, your voice. They are the reason your body can build itself, heal itself, and even defend itself. Nucleic acids are the language of life, but they are not just in you. They are in every living thing, from the smallest bacteria to the tallest trees. Every living thing is built by the code of nucleic acids. Level 84. DNA and RNA. DNA and RNA are the two most important molecules in your body. They are the carriers of genetic information. They are the instructions that tell your body how to build itself, how to repair itself, how to function. DNA is the master copy. It is found in the nucleus of your cells, where it is protected. It is a double helix, a twisted ladder of nucleotides. Each step of the ladder is made of two nitrogen bases that pair together. Adenine pairs with thymine. Cytosine pairs with guanine. This code is what makes you who you are. Your DNA is a unique combination of these base pairs, a code that decides everything about you, from your hair color to your blood type. But DNA does not do the work. It stays safe in the nucleus. Instead, it sends a copy of its instructions using RNA. RNA is the messenger. It is a single strand of nucleotides. It is like a portable copy of your DNA, but with one difference. Instead of thymine, it has uracil. RNA takes the instructions from DNA and brings them to the ribosomes, which are the factories that make proteins. Without RNA, your DNA would be useless. It would be a library with no way to share its knowledge. DNA and RNA are the reason life can exist, grow, and change. They are the code that makes you who you are. But they are also a reminder that even the most powerful instructions are nothing without someone to follow them. DNA is the master plan, but RNA is the builder. Together, they are the secret of life. Level 85. Chemical Kinetics. Chemical kinetics is the study of how fast a chemical reaction happens. It is not about what the reaction is, but how quickly it takes place. Imagine you are cooking a meal. You put a pot of water on the stove. If you turn the heat to high, the water will boil quickly. If you set it to low, it will take much longer. This is chemical kinetics. It is about the speed of a reaction and what can change that speed. In chemistry, reactions can be fast or slow. Some reactions, like lighting a match, happen in an instant. Others, like the rusting of iron, can take years. But what makes a reaction fast or slow? Temperature is a big factor. Higher temperatures usually make reactions happen faster. That is why food cooks faster in a hot oven than a cold one. Concentration is another factor. If you have more of a substance, the reaction can happen faster. Imagine a crowded room full of people. If everyone is trying to find a partner to dance with, they will find one quickly. But in an empty room, it takes longer. This is like molecules in a reaction. The more there are, the faster they collide and react. Catalysts are also important. These are special substances that speed up a reaction without being used up themselves. Think of a crowded room with a dance instructor who helps people find partners faster. That is what a catalyst does. Chemical kinetics helps us understand and control reactions. It is why medicines are designed to work at the right speed in your body. It is why car engines burn fuel efficiently. It is even why you can bake a cake without burning it. It is the science of timing, the study of speed, and the secret to making reactions happen exactly when we want them to. Level 86. Thermodynamics. Thermodynamics is the study of energy and how it moves. It is the science of heat, work, and how they affect everything. Every time you boil water, burn a match, or even breathe, you are seeing thermodynamics in action. The most basic idea in thermodynamics is that energy cannot be created or destroyed. It can only change from one form to another. This is known as the first law of thermodynamics. Imagine you are holding a warm cup of tea. The heat from the tea moves to your hands, making them warm. This heat is not disappearing. It is simply moving. This is energy changing form. But thermodynamics is not just about heat. It is about understanding how energy works in all systems. Your body uses thermodynamics too. When you eat food, your body breaks it down and turns it into energy. This energy keeps you warm, helps you move, and even lets you think. The second law of thermodynamics is also important. It says that energy naturally moves from being ordered to being disordered. This is why a hot cup of tea always cools down. It loses heat to the room until it is the same temperature. This idea is connected to entropy, which we will explore next. Thermodynamics is used in so many places. It is in the engines that power cars, the refrigerators that keep food fresh, and even in your own heartbeat. It is the study of how energy travels, how it changes, and how it controls everything in the universe. Level 87. Entropy. Entropy is a simple but powerful idea. It is a measure of how disordered or random something is. But what does that mean? Imagine you clean your room perfectly. Everything is in its place. The bed is made, the clothes are folded, the floor is clear. This is low entropy because everything is in order. But as time goes on, something happens. A book is left on the floor. Clothes are thrown on the bed. Your shoes are kicked under the table. The room becomes messy. This is high entropy. Things naturally move from being ordered to being disordered. This is the idea of entropy. It is why a hot cup of tea cools down, why ice melts in your drink, and why a burning log turns into ash. It is nature's way of spreading out energy. Entropy is not just about messiness. It is about how energy is shared. In a crowded room, people spread out naturally. That is entropy. Even your own body follows this rule. When you eat, the energy from food is spread out to keep you warm, help you move, and keep you alive. Entropy is also why it is easier to break something than to fix it. Breaking a glass increases entropy because the pieces are more spread out. Fixing it would mean reducing entropy, which takes work. But entropy is not always a bad thing. It is why the universe is constantly changing. Stars burn out, planets form, and life begins and ends. Entropy is the silent rule of nature, the quiet push that turns order into chaos. Level 88. Enthalpy. Enthalpy is a concept that helps us understand how much energy is in a system. It is like the total energy that something has, including its heat. But how do we understand this? Imagine you are sitting by a warm fire. You can feel the heat on your skin. This heat is part of the enthalpy of the fire, but there is more. The wood burning in the fire has energy stored in it. This energy is released as heat and light. That is part of the enthalpy too. Enthalpy is about the heat a system can give off or take in. In chemical reactions, enthalpy is important because it tells us if a reaction will release energy or absorb it. Think of an ice pack that you use for an injury. When you break it, a chemical reaction starts. But instead of getting hot, the pack gets cold. This is because the reaction is absorbing heat. It is an endothermic reaction, and its enthalpy is positive. But when you burn a piece of wood, it gives off heat. This is an exothermic reaction, and its enthalpy is negative. Enthalpy helps us understand energy in a simple way. It tells us if a reaction is warm or cold, if it gives energy or takes it away. It is why some reactions feel hot and some feel cold. It is why food gives you energy when you eat it. It is why your car engine can turn fuel into motion. Enthalpy is the hidden energy in everything. It is the quiet heat that keeps your world warm or cool. It is the energy that can light a fire, heal a wound, or power a machine. Understanding enthalpy is understanding the energy that surrounds you and keeps you alive. Level 89. Gibbs, free energy. What would you do if you stood at the edge of a cliff, the wind howling against your face, and below was a deep, dark sea? Would you jump or would you turn back? That moment, that feeling in your chest, that pull of fear and curiosity, is like Gibbs' free energy. It is the invisible force that decides if something will happen or not. In chemistry, Gibbs' free energy is the energy that tells you if a reaction will happen on its own. It is like having a choice in a dangerous situation. If the energy you have is enough, you take the risk. You make the move. If it is not, you hesitate. You hold back. Imagine a man staring at a door. On the other side is everything he has ever wanted, but opening it means losing what he has now. His heart races, his hand trembles, he wants to move but he is frozen. That is Gibbs' free energy choice between action and hesitation. Level 90. Phase changes. Have you ever watched someone you love change before your eyes? Someone who was once so warm, so kind, suddenly becoming cold and distant. That is a phase change. It is the same person, but something has changed inside them. In chemistry, phase changes are when a substance changes from one state to another: solid to liquid, liquid to gas, gas to solid. Imagine a child holding an ice cube in their hands, watching it melt, feeling the cold water trickle down their fingers. It is still water, but it is different. It is not a loss, but a transformation. Just like how people change, not because they become someone else, but because they become something else. Level 91. Boiling point and melting point. Have you ever reached a point where you could not take it anymore? Where the pressure, the pain, the frustration reached a level where you had to scream, cry, or walk away? That is your boiling point. And just like people, every substance has a boiling point and a melting point. It is the temperature at which something can no longer remain the same. Imagine a pot of water on a stove, bubbles forming slowly, then faster, then a storm of boiling. That is the boiling point, the moment of release. Or think of an ice cube in a beautiful girl's hand, slowly melting, a drop of water sliding down her fingers. That is the melting point, the moment of surrender. In life, we all have our limits, and so do things around us. Level 92. Sublimation. Have you ever lost something without a trace? A friend who suddenly disappears, a feeling that vanishes without warning, a love that fades without a goodbye. That is sublimation. It is a transformation that leaves no trace, a change from solid to gas without ever becoming liquid. Imagine a beautiful snowflake landing on a warm palm, but instead of melting, it just disappears. It is gone, as if it was never there. Or picture a boy drawing on a frosted window, but as the sun rises, the frost does not melt, it simply fades away. Sublimation is the reminder that some things do not change slowly. They vanish completely, leaving you wondering if they ever existed at all. Level 93. Deposition. Deposition is a process that seems like a magic trick. It is when a substance goes directly from a gas to a solid without becoming a liquid. It is like skipping a step. It is like seeing steam turn directly into frost without ever becoming water. But it is not magic, it is science. Deposition happens when gas particles lose so much energy that they do not have the power to become a liquid. They lock together as a solid instead. You see this in the winter when frost appears on cold surfaces. Water vapor in the air turns directly into ice crystals without ever becoming water. This is deposition. It is the opposite of sublimation, where a solid turns directly into a gas. Think of dry ice. It does not melt into water. It turns straight into carbon dioxide gas. That is sublimation. But deposition is the other side of that coin. It is a process of freezing without the liquid stage. You also see this in making artificial snow. Compressed air is blown over very cold water vapor, and it turns directly into tiny ice particles. This is deposition turned into a tool. But deposition is not just about ice. In space, where temperatures can drop instantly, gases can turn into solid frost on the surface of spacecraft. In manufacturing, thin layers of metal can be deposited onto surfaces using a process called vapor deposition. Even the soot from a candle flame can deposit on a surface, creating a black layer. Deposition is everywhere, once you know what to look for. It is a reminder that change is not always a smooth transition. Sometimes it is an instant transformation. Level 94. Critical point. The critical point is the extreme limit of temperature and pressure, where a substance stops behaving like a normal liquid or gas. It is where the line between liquid and gas disappears. Imagine a pot of boiling water. You see the water as a liquid at the bottom, and you see steam rising as a gas. But if you increase the temperature and pressure beyond a certain point, something strange happens. The water and steam become one. It is not a liquid, and it is not a gas. It is something in between. This is the critical point. Every substance has its own critical point, a unique combination of temperature and pressure where it stops behaving normally. For water, the critical point is 374 degrees Celsius and 218 times the normal atmospheric pressure. Above this point, water becomes a supercritical fluid. It can dissolve substances like a liquid but flow like a gas. This is not just an idea for scientists. The critical point is used in real life. In power plants, water is heated beyond its critical point to become a supercritical fluid. This makes the plant more efficient because supercritical water transfers heat better. Even in coffee making, critical point technology is used. Supercritical carbon dioxide is used to extract caffeine from coffee beans. The critical point is a reminder that there are limits to everything. Even the way you understand liquids and gases has a breaking point. It is a place where the rules you know stop working, and something new begins. Level 95. Supercritical fluids. Supercritical fluids are not something you see every day, but they are one of the most useful secrets in science. A supercritical fluid is a state of matter that is not a liquid and not a gas. It is both and neither at the same time. It happens when a substance is heated and compressed beyond its critical point. At this stage, the substance takes on the properties of both a liquid and a gas. It can flow like a gas, filling a space, but it can also dissolve substances like a liquid. Supercritical fluids are powerful tools. One of the most common is supercritical carbon dioxide. It is used to make decaffeinated coffee. The beans are soaked in this supercritical fluid, which dissolves the caffeine but leaves the flavor intact. It is also used to extract essential oils from plants, creating pure perfumes and flavors without using harsh chemicals. Supercritical fluids are even used in cleaning delicate electronics. Because they can flow like a gas but clean like a liquid, they can remove dirt without damaging sensitive parts. They are also used in the pharmaceutical industry to create pure, concentrated medicines. But how can something be both a liquid and a gas? The answer is that at the supercritical stage, the molecules are free to move like in a gas, but they are close enough to interact like in a liquid. It is a reminder that the world is not always as simple as it seems. Even the idea of a solid, a liquid, and a gas has its exceptions. Supercritical fluids are the proof that there are always states you cannot see but can still use. Level 96. Electrochemistry. Electrochemistry is the science of electricity and chemical reactions coming together. It is how your phone battery works. It is how metal is protected from rust. It is how your nerves send signals. It is a field of science that hides in plain sight, but it is part of your everyday life. At its heart, electrochemistry is about the movement of electrons. When electrons move, they create electricity. But in electrochemistry, this movement happens because of chemical reactions. Think of a battery. Inside, there are two chemicals separated by a barrier. One side wants to give up electrons. The other side wants to take them. This difference in desire creates a flow of electrons through a wire, which is the electricity that powers your devices. This is electrochemistry. But it is not just about batteries. Electrochemistry is used in electroplating, where a metal object is coated with a thin layer of another metal to make it look shiny or to protect it from rust. It is used in water purification, where electricity is used to separate impurities. Even your own body uses electrochemistry. Your nerves send signals using tiny electrical pulses. Your heart beats because of electrical impulses controlled by electrochemical reactions. But electrochemistry can also be dangerous. When a car battery leaks, the acid inside can burn you. When electrical wires touch water, they can create deadly shocks. Electrochemistry is a reminder that even the smallest particles, electrons, have the power to create, to protect, or to destroy. It is a field where the invisible becomes powerful. It is the hidden force that powers your world. Level 97. Galvanic Cells. Galvanic cells are like tiny, invisible battles where electricity is born. But it is not a battle of people, it is a battle of atoms. Galvanic cells are devices that take the energy from a chemical reaction and turn it directly into electricity. Imagine two metal strips placed in two different liquids. These metals are called electrodes, and the liquids are solutions filled with tiny charged particles called ions. One of these metals loves to give away electrons. It is like someone who always gives gifts. The other metal is hungry for electrons. It is like someone who is always taking. When these two metals are connected, electrons start to flow from one to the other. This flow of electrons is electricity. But this is not just a simple flow, it is a race. One metal gives away electrons and becomes positive. The other metal takes electrons and becomes negative. The electrons move through a wire, and that movement is what creates electric current. That is the power of a galvanic cell. It is how a battery works. The battery in your phone, your laptop, even the small batteries in your remote control, all work because of this idea. Even the first battery ever made by Alessandro Volta in 1800 was a simple galvanic cell. But there is a hidden depth to galvanic cells. They are not just about electricity. They are about control. By changing the metals or the solutions, you can change the strength of the electricity. It is like having a tiny, controllable lightning storm in your pocket. Galvanic cells are the reason you can talk on your phone, light up a room, or even start a car. They are the silent creators of electricity, using the quiet power of chemistry. They are proof that even the tiniest particles can create something powerful. Level 98. Electrochemical Cells. Electrochemical cells are not just about creating electricity, they are about controlling it. These cells are devices that turn chemical reactions into electrical energy or turn electrical energy into chemical reactions. They are a two-way street. There are two main types of electrochemical cells. One is the galvanic cell, which you already know. It creates electricity from a chemical reaction. But the other is the electrolytic cell. This one is different. Instead of making electricity, it uses electricity to make a chemical reaction happen. Imagine a piece of silver jewelry that has lost its shine. You place it in a special solution and connect it to an electrolytic cell. Slowly, a thin layer of shiny silver appears on the jewelry. This is because the electricity is forcing silver particles to attach to it. That is an electrolytic cell. It is not just for jewelry. Electrochemical cells are used to purify metals, to create special chemicals, and even to protect metals from rusting. They are in your car battery, where they help store energy. They are in your kitchen, where they help make aluminum foil. Even the process of making chlorine for your swimming pool uses electrochemical cells. But there is something even deeper. Electrochemical cells show us that electricity is not just something you see, it is something you can control. You can make it, you can use it, you can store it. You can even force it to change the world around you. It is a reminder that electricity is not just light and power. It is a silent force that can create or destroy, build or break. Electrochemical cells are the hidden power of chemistry and electricity working together. Level 99, Quantum Chemistry. Quantum chemistry is the strange, invisible world of atoms. It is a world where particles do not behave like solid objects. They act like waves. They are here and not here at the same time. This is not science fiction. It is the reality of the smallest particles in the universe. Quantum chemistry is about understanding how these particles move, how they bond, and how they create everything you see around you. It is about electrons jumping between energy levels like tiny lightning bolts. It is about atoms that can be two things at once. Imagine you are looking at a light. To your eyes, it seems like a steady, warm glow. But in the world of quantum chemistry, that light is made of tiny particles called photons, which are jumping and moving in ways you cannot see. Even the simplest atom, hydrogen, is a quantum puzzle. Its single electron does not move like a tiny planet around the nucleus. It moves like a cloud, a wave of possibilities. Quantum chemistry is the reason we have lasers, which are just perfectly controlled waves of light. It is the reason we have computers, where tiny electrical signals move through quantum particles. Even the colors you see in a rainbow are created because of quantum chemistry. But quantum chemistry is not just about science, it is about a mystery. It is about how something can be both a particle and a wave. It is about how electrons can exist in more than one place at the same time. It is about understanding that the world is not as simple as it seems. It is a reminder that even in the most ordinary things, there is a world of strange beauty hiding beneath the surface. Quantum chemistry is the science of the impossible made real. Level 100, Chemical Bonding Theories. Chemical bonding theories are the secret to understanding how everything around you is held together. They are the reason water stays as a liquid, the reason your muscles move, and the reason diamonds are so hard. But what are chemical bonds? They are the invisible connections that hold atoms together. There are different types of bonds, each with its own rules. The most basic type is the ionic bond. This is when one atom gives away an electron and another atom takes it. It is like two people trading gifts. Sodium and chlorine do this to create salt. Sodium gives away an electron, becoming positive. Chlorine takes it, becoming negative. The positive and negative charges attract each other, creating a strong bond. Then there is the covalent bond. This is when two atoms share electrons. It is like two people holding hands. Water is made this way. Oxygen shares electrons with two hydrogen atoms, creating a stable molecule. But there are even stranger bonds. Metallic bonds are found in metals. They are like a sea of electrons flowing around a group of metal atoms, making them strong and shiny. Even the air you breathe is held together by bonds. The oxygen and nitrogen in the air are connected by covalent bonds, and there are even hydrogen bonds, which are weak but important. They are what hold the two strands of your DNA together. Chemical bonding theories are not just about connections. They are about understanding how atoms work together, how they share, steal, or give away their tiny particles. They are the reason you can drink water, eat food, light a fire, or even read this text. Chemical bonds are the invisible threads that hold everything together. They are the quiet, unbreakable force that creates and shapes your world. And that's it. Hope you're in peace. Just consider subscribing, because sleep matters. Just then, stress scatters and nothing else matters, right? Peace out.